And before we come to the lectures, before we come to the speakers today and to the Petra Kutscher inputs and the talks, I'm very happy that Gerhard Bast, Rector of the University of Applied Arts, is here today. And he'll open this hybrid symposium here live at the Angewandte, but also at home or on the beach or wherever you are sitting officially to us. Gerhard, may I kindly ask you? Thank you.
So thank you very much, Wojtek, also for your introductory performance. It was a really meaningful step into this topic. I welcome you here in the auditorium of the Angewandte physically, and all of you at home on your screens, as we have been used to do so in the last 1.5 years. Sometimes, so I was, we already got a little tired of just sitting on the screen for hours and hours. So I'm really happy that we now have the chance again to make a symposium and a discussion also in a physical mode. So, how will we live together? No, you are not in the wrong event. This came in my mind last night when I asked myself, what should I say? And probably a lot of us, like me, traveled to Venice in the last months with a lot of expectations, aspirations, hoping to find some answers to this really important question. And it's, this is my opinion, it came out that like so often, not only at the Biennale and the Architecture Biennale, but also in other events, which raised really important, meaningful questions or topics. Also, Ars Electronica is an example. The new digital deal they claimed this year, that we really did not find masses of proper answers, although the whole world of architecture, the whole world of art is present at such events. But in my opinion, and I'm convinced of that, this does not mean that we should not, we must not raise such kinds of questions, that we should not ask such kind of big questions. And of course, we could fail, but especially in this environment, at an environment of a university, we have to raise these kinds of big questions, like you did. And maybe at the university, in this kind of environment, of this discursive environment, there is a bigger chance to get into the topic in a more relevant way, in a way that we can leave the event with at least some incentives for our future thinking. This is what we at this university want to provide. It's not just about answers. It's about giving incentives to think beyond the present mainstream. A mainstream we very often find in such big events like biennales or big blockbuster exhibitions. It's not about answering along the mainstream. It's not about answering questions within the framework of a single discipline. It's looking together many disciplines. And one of the few sentences which I still remember, which I read in Venice last month, was, "The city does not belong to a single discipline." And this is not just about the city, it's about the future. The future does not belong to a single discipline. And even more, we are obliged to bring together seemingly different disciplines. And maybe it's interesting that already Friedrich Kiesler, many, many years ago, had this approach, bringing together architecture, technology, physics, and also humanities, to be able to find some new ways to meet the challenges of the civilization. And the challenges we have now are even more challenging than some decades ago. So we have to meet these challenges soon. We are losing time from day to day, and we have to think in dimensions beyond the mainstream disciplinary way, which is a way academia, universities are used to. But this university is trying hard to step aside these also academic mainstream. And therefore I'm happy that we now here again have many important representatives of thinking beyond the mainstream, and I thank the organizers, and especially Karin Reit, for again organizing this symposium, and I wish you all a fruitful and interesting and an inspiring symposium and debates. Thank you very much.
Thank you, Gerald, for your opening words. You just mentioned one name. I'll add another one. I was talking and preparing for this conference with two people before that, Karin Reit and Lukas Allner, initiators and organizers of this event today, and I would like to welcome you on the stage here. We have a few questions to you. Would you just grab a microphone? Is it microphones on? Yes, sounds so.
Yes.
Last year you started with the Circular Strategies Symposium. So last year was episode 1. Today we have episode 2. How did you start? What was, let's say, the pain that you felt to start with such a huge project?
Well, we felt that this very important topic was not addressed sufficiently at our department, and so we decided to set up a specific focus there in teaching, in research at the Department of Building Construction, and we organized this first symposium as a kind of kick-off event. Yeah. And we thought it is especially important to establish that topic in architecture, because linear economy, which produces such an enormous consumption of resources and such an enormous emission of CO2, should urgently turn into a circular economy. And therefore we thought this has to be a discussion has to be sparked and fueled, especially among the young people who are present at the university, because they are the thinkers and the actors in the future. And yeah, so this was the main idea. And last time we gave a more general overview because the topic was new in our field. And this time we choose this specific focus.
Lucas and Garrett Buss just mentioned that's it's about giving incentives to think beyond the mainstream. How far are we when it comes to circular economy, to circular strategies in giving incentives? Are we at the beginning or are we already in the midst of the process?
I think it very much depends on the context. It's in some ways it's in the midst of the process, I would say, but in some other areas of the discipline and related disciplines, it's only at the beginning, whereas in others it's already quite established. So, for example, in industrial processes, for example, car parts are already almost fully reused to some extent, but in architecture, for the most part, it's still rather linear process, what we are talking about. And we realized over the course of the last 2 years that we dived into this topic more, that there are no such things as concrete answers or solutions to this complex problem. And therefore, we tried in this event to collect many, perhaps even contradicting ideas and thoughts, really as incentives. That's, I think, a great term. To invite people to engage with the sort of thinking in the direction, towards the direction of an alternative future building culture.
You're one of the guys who also developed the graphic design for this conference. We have two circles, we could say. One, which is a linear circle, and let's call it a perfect circle. And the other one is not a linear circle, and maybe it's not perfect in a classical sense. Do you have a favorite?
No, not really. And we should not put too much symbolism in these graphics. But yeah, that's true that we wanted to contrast two approaches in this conference. The one that is more for reduction, for minimizing the material input, for minimizing also the energy that is embodied in the material, and in this way also the CO2 emissions. And on the other hand, a kind of thinking that wants to prepare buildings for the future in a way that they are not optimized for a specific situation, but they provide a little more. They provide possibilities to change the program of a building in an easy way, yeah? Without requiring a lot of further input of material and energy. Yeah? So I think that this will be one of the most important challenges in the future, to invest our creativity in working with what is already there, yeah? In changing buildings with minimal interventions, with intelligent interventions, so that even old buildings can fulfill new purposes. Yeah? And these two contrasting poles, they also set a kind of frame for our symposium today. And I'm very curious to learn whether these two exclude each other or whether they could be combined. And we will see in which situation and in which context one approach does make more sense and in which context the other one.
Thank you, Karin. Lucas, do you have a favorite?
I would like I think, no, I'm not going to say.
That's a political answer. But then let me ask you one thing.
No, I wanted to add something to what Karin just said. I think what we are interested in, beyond this obligation to engage with the idea of making the world better, we strongly believe that that the thinking in this direction not only could solve problems, but it also offers potential and opportunities for new concepts altogether. And that's what we are looking for also today, that it's not only about an obstacle to overcome, but it's also it's a chance for a new future.
That sounds like a perfect invitation and a step to the first keynotes. Thank you very much. So let's use this chance, and thank you very much for your impulse and for your initiative that you took, and also for your effort. Karin and Lucas. So let's come to the first keynote. You will see that today we have altogether 5 sessions. And as we have to kind of bring together the real symposium with the digital virtual symposium, we decided to stick rather to a short digital structure. So every slot will be a little bit less than 1 hour. So starts always on the full hour and ends just a few minutes before the next hour. So this one will start now at 10 and end roughly at 10:50. Then you have 10-minute bio break, and then we'll continue all the way until the afternoon. And sometime in between, of course, we will also make 1 hour lunch break. So whenever you at home, in your office, again, at your beaches or in your gardens, have to interrupt, we'll always start on the full hour again. First slot, Principles of Material Optimization. And Jan Knippers, who will join us digitally now, will have the keynote lecture. ITKA University in Stuttgart in Germany. And Jan Knippers is a consulting structural engineer interested in innovative and resource-efficient structures at the interface of research and development and practice. He co-developed a robotic winning process for fiber composite systems that enables novel lightweight construction systems. And today he will be talking to us about those principles of material optimization. I wanted to check, Jan, are you already with us?
I'm here, yes. Can you hear me?
Good. We can hear you, and we can also see you perfectly. How is the sound? Can you hear us well?
I can hear you perfectly.
Perfect. Then the stage is yours, and we're looking forward to your keynote. Thank you.
So thank you for inviting me. I'm also so sorry that I cannot be in Vienna today. I'm really, as all of us, I'm so tired of these video conferences. I would love to be with you in Vienna and to see and talk to you, but for some reason this is not possible today. But I'm very happy that you invited me and gave me the opportunity to present some of our works, to share some ideas, and to have hopefully a fruitful discussion at the end. So Principles of Material Optimization, that's the title that was chosen by, I think, Karin and Lucas for this session. And that's a pretty interesting topic because optimization is, for us engineers, very important. Engineering is all about optimization. We search for the lightest, the strongest, the widest, the largest, the safest structure. This already indicates that optimization is always associated with a goal. If we talk about optimization, we have to define the goal of our optimization. And this goal is changing according to the challenges of the respective time. And I think one of the biggest problems that we are facing in the building sector is that we are using building systems that were optimized for different goals than the one that we consider as the most important ones today. Today, I think we all agree that to minimize the ecological impact of our buildings is the most important goal that we are facing at the time. But these goals are changing, as I said. And if you look at, for example, at steel reinforced concrete, this is an invention of the late 19th century. After a series of devastating fires in cotton mills and other buildings, the development of reinforced concrete was mainly driven by the urgent need for fireproof structures for railway stations, mills, market halls, as this one. And the main goal of the first generation of concrete architects and engineers was to explore and demonstrate the full potential of this new material system by load-adapted and wide-spanning structures, as this one that you can see here. But this changed already pretty soon for the second generation of architects and engineers that work with concrete, for this generation of engineers and architects, concrete was already a standard building material, a well-established building system, and they pursued totally different optimization goals, as mostly rapid erection for mass production of low-cost housing. You can see this famous Maison Domino that all of you know. That is a sketch from the 27-year-old Le Corbusier showcasing a concrete skeleton for low-cost buildings. And there were already early attempts to improve the material efficiency of these kind of concrete skeletons. All these famous examples that you see here, that all of you know, these ribbed ceilings, these mushroom heads, to reduce material consumption of this kind of concrete slab systems, skeleton systems. But all these developments came to an end in the 1960s, 1970s, because during the course of the 20th century, material became cheaper and cheaper, and labor became more and more expensive. So today, we more or less use quite exactly the same building systems that were designed by Le Corbusier 100 years earlier. All the building systems that we use in practice today are optimized for rapid and fast design and construction. So all the columns are the same, all the slabs are the same, even though the loading is very different at the different points of the structure, because it makes literally no difference if we use 10, 20, or 30% of concrete, but it makes a big difference if we need 10, 20, or 30% more time for design and construction. And climate crisis now forces us to rethink this paradigm. If we include the environmental cost of concrete, the assessment suddenly changes dramatically. Here you can see the greenhouse gas emissions in the construction sector subdivided by source, and the largest bar on top is the production of cement. So there's a common understanding today that the most urgent goal is to reduce the carbon dioxide emissions related to concrete structures. So the first thing we have to do is to think of lighter and more material efficient cement structures. And here, digitization, for example, enables new systems for more material efficient concrete structures, because digitalization supports manual labor, reduces manual labor, and makes these systems more efficient. But still, we have to face the fact that the production of cement, the heating of limestone, as well as the heating of iron ore is associated with chemical reactions that lead to carbon dioxide emissions. So even the most efficient, lightest, best engineered cement or steel structure is still related with carbon dioxide emissions. And the only strategy that we have today is to capture the carbon dioxide, to compress it, and to store it somewhere under earth, and this, of course, is also related with some problems. So the challenge is we need new building systems, new paradigms in building structure that replace this kind of concrete and steel and cement structures. And this is why I think we have to leave this path of optimization. We have, as I said, search for new systems. And our key graph of the research that we are doing in Stuttgart is this one, indicating that the joint research on design methods and fabrication processes, the feedback-oriented, open-ended research is hopefully leading to totally new building systems that replace the ones or substitutes the ones that we are using today. And I want to illustrate this a bit by showing these two projects that we have done at the Federal Gardening Show in Heilbronn in 2019, showing the two directions of research that we are pursuing. All the projects I'm showing here are joint projects of the group of Achim Menges, who you all well know, and my group. So I don't have to repeat this every time again. So the first one is this carbon fiber structure, the carbon fiber dome. You can see on the top left. This one, we see this one as an example how these research, fundamental research on computational design and fabrication can lead to totally new building systems that were not possible without the help of digital fabrication. It's a dome structure, 24-meter span, consisting of this bone-like components. This is a fiber winding process. It was mentioned in the introduction that we are working on since more than 10 years now. The idea is that fiber composites are omnipresent in all fields of technology except the building sector. And that's why, because all the fabrication processes for fiber composites are oriented towards the serial production of identical components, as for example, blades of windmills or components of the aircraft industry. And we need a production process that is adapted to the specific needs of architecture and building construction, which means simple, reliable processes that allow for easy adaptation of the geometry of the components to different conditions. So we have this rotating steel frames. We first place the white glass fibers, cheap but weak, and they form this hyperbolic body. And then we wind the strong carbon fibers, stronger than steel, that take the loads. The fibers are wet, resin impregnated. We put the whole package in an oven, temper it, and after a couple of hours, you get this very hard and very strong component that you can see here on the bottom right. And in an ideal world, we have exactly as many black carbon fibers as we need to carry the loads. We have no cutoff of fibers, and we have no waste for molds or foams, no ugly polyurethane foam. So it's a very resource efficient, a very light production process. Yeah, you can see here again, in the meantime, at the beginning, this was a very rough process. In the meantime, we step by step improved it. The carbon fiber spools, the black ones, the dry ones here, and they are pulled through this resin bath and then placed here on this rotating frame. I think I have a video here. Yes, here you can see it. This is real speed. The black carbon fibers wound around the pins, and the entire package is tempered in an oven for 8 hours. And what you get then is a very hard and strong component. One of these components weighs around about 80 kg and carries 250 kN, kilonewton, 25 tons. What's also an interesting aspect, at least from my perspective as an engineer, is that all building construction that we are doing today rely on an analytical prediction of the load-bearing capacity. So when we do a building, we have to predict, anticipate the integrity of the system by structural analysis. That's kind of a fundamental difference to other industry sectors, as the automotive industry, where we rely on test runs and prototypes. And here it's interesting to see that this kind of digital fabrication enables this finely tuned structures, and we of course can simulate the flow of forces, but what we cannot do is we cannot predict kind of the load bearing capacity, and that's why we rely on this full-scale tests. And I find this pretty interesting because this is kind of 19th or 18th century engineering approach, trial and error approach, that the kind of you're thrown back to this trial and error approach, even though you're using the most advanced fabrication technologies. It's kind of interesting side aspect for us engineers here. Okay, they have this cover by this stretched ETFE foil. What's the new architectural, haptic, visual expression that comes along with this fiber composites? And as I said, in an ideal final stage of development, we aim for putting exactly as many fibers as we need to carry the loads without any waste and cutoffs of material. And that's where we see the potential of these systems. Of course, the first question that always comes, you're doing all these nice and crazy pavilions and shells and domes. How can you use these systems in the real world for multi-story buildings, for example? And that was the question that we wanted to answer with our installation at the current Biennale in Venice, that probably some of you have seen. Here you can see an image from the construction stage, the fiber body carrying the load, and the thin LVL plate that acts here as a slab, structurally supported by this fiber body. Yeah, and this here you can see the entire team in the first on the first level. You don't feel any deformations, any vibrations, so structural capacity is zero problem here. The main challenge is more on the long term, is more durability of the material system, fire resistance. So there are more material related questions than fabrication or structure related questions that need to be addressed in the next steps. So this we see as an example for a totally new building system that was made possible only through fundamental open-ended research on digital fabrication processes. And the weight of this system is 30 to 40 times lighter than a comparable concrete structure of same capacity. Going one step further, we know that with all these materials, also with glass and carbon fibers, of course, carbon dioxide emissions are related to the production of these materials. So even the best, most efficient, best designed concrete or steel structure is associated with emissions, carbon dioxide emissions, and or to put it a bit kind of oversimplified, every new concrete, steel, but also carbon composite structure is bad for the climate. And we can also only turn this around if we use these dark blue box here, which indicates the potential of bio-G materials to store carbon dioxide. So we have to replace these conventional building materials by bio-based materials if we really want to arrive at a kind of greenhouse gas neutral building constructions. Here, this is a graph from the group around Jörg Schellenhuber from the Potsdam Institute for Climate Research, which I like very much, which indicates that for millions of years, the concentration of carbon dioxide in the atmosphere was reduced by forming a carbon pool in a terrestrial carbon pool in form of coal, gas, and oil, and that this pool was depleted with the beginning of the Industrial Revolution, and the resources the fossil resources were used to produce steel and concrete and cement. And this led to this kind of increase, the raising carbon dioxide concentration in the atmosphere. And the only way that we have now to turn this around again is to replace concrete by timber and other bio-based materials, and to use the building as a kind of storage for carbon, and to, by this, reduce the carbon dioxide concentration in the atmosphere by replacing these trees, this wood, by new, by planting new trees. But if you look at and that's why we have, but that's why it's absolutely necessary to promote timber construction. And this is a kind of random selection of current timber buildings. But if you look at them, you can see that the architectural as well as structural spectrum of these buildings is still very limited. Regular buildings, small spans, regular spans, unidirectional slabs. So very limited application scenario compared to steel or concrete structures. And this is the aim of our second project, was the aim of our second project, to indicate, to show how digital fabrication tools could widen the application scenario for timber structures, could enable the use of timber for more complex buildings in a kind of economic and efficient way. Yeah, this is a Buga shell, 30-meter span, consisting of planar plates that show a different geometry. These are 247 plates. Each one has a different geometry. You can see the lower three levels here show the load-bearing system. The load-bearing plate transferring the membrane forces, the edge beams transferring the forces from one component to the next one, and the bottom plate stiffening it. And on top we have this drainage and the cladding here. A digital model containing all the information for fabrication, and then the mobile robotic platform that was installed at the shop of the timber manufacturer near Ulm. So it's kind of also should kind of indicate also to the industry how they could use this kind of technologies for their in their workflow. On the left, robot picks and places the components, and the right one processes it. You can see here putting the glue, temporary fixing of the edge beams, and then glue again, and then the entire thing is lifted to the hydraulic press. And after this, the edges are milled. Here again, you can see how the one places the glue and picks the edge beams. And finally, here you can see temporary fixing of the edge beams, placing the glue, the top plate, and milling of the edges is the final step after curing of the glue. Here you can see the milling. Yeah. Also here you can see how we investigated the production time of the individual steps, and you can see that the assembly, the first part in the first video, is only 7 minutes per cassette per component, but the milling, the formatting of the edges takes nearly 1 hour. So the next step, if you think about further optimization of these systems, is to reduce the effort by, for example, replacing the finger joints here by other means of connection of the components. We also monitored accuracy, less than 1 millimeter deviation between the planned geometry and the actual built one. And one is here, one of the main advantages of these systems is that you don't need any scaffolding or formwork, because the relation of weight to stiffness is very good. So low weight, but high stiffness. That's why we only had to support the edge beams here by these 3 posts. That was all we needed here. And this makes the systems very cost efficient compared to concrete shells where all the money goes into the formwork. Placing here, this was a final component. You can see how everything fitted quite well. Final component on top. You can see here what was really painful, and this will be then the next step. It was really painful to place this bolts on top overhead with limited visual control. And this is then the next step to also bring exoskeletons or other digital means on site that assist manual labor and supports assembly on site. Final shell. Was very nice to see that this was also a very well accepted space. There were concerts every day, also because of the very good acoustics that we had here due to this hollow cassettes. Yeah, that was Heilbronn. And we now also try to transfer these ideas, these concepts of the light hollow systems to regular multi-story buildings. We use the same fabrication platform to produce now slabs that somehow display the same structural freedom, architectural freedom as point-supported concrete slabs. One final project is where all this comes together is a very small one, which was just completed a few weeks ago in Freiburg, but a very important one, a very important step forward for us, which is this flux pavilion that you can see here in Freiburg, a small structure, small dome-like structure made out of flux fibers and covered by this polycarbonate sheet. You can see here what we usually use in all technical application, the glass fibers at the left, cheap and weak, as I said earlier, and the carbon fibers, strong and expensive. And now we, of course, are always confronted with the questions or with the comments that we talk about light and resource efficient structures, but use this kind of very energetic carbon fibers. So the idea is, of course, pretty obvious to replace these carbon fibers by natural fibers. You can see here the flux fibers, flux fiber rovings, natural flux fibers, or synthetic bio-based cellulose fibers. You can see here just a quick look at the charts that the mechanical properties of these natural fibers are in a similar range, I would say, as glass fibers. A little bit weaker, stiffness is similar, strength is a bit less, so it's kind of in a similar range as this kind of synthetic fibers that we use for technical applications. What is very important is that flux is a regional resource. It's planted and harvested in Central Europe as hemp. So hemp and flux are the two regional reinforcement fibers that are used, for example, in the car industry, while others, as sisal and cocos, needs to be imported from Southeast Asia. And what is also very important compared to timber or wood is that this is kind of annual resource. So if I plant a tree today, it can be used as a building material in 60, 70, 80 years. And we know that during this time of rapid climate change, the resource wood is prone to many risks as fire or thunderstorms. And that's why it's important also to look for other bio-based resources, as, for example, this flux fibers that we use here in this kind of technical form that you can see here, made out of this weekly resource. Fabrication process is the same. And it's also interesting that it provides a very different aesthetical appearance, even though the process and the idea behind it is quite similar to these carbon structures, because properties, mechanical properties are below carbon. We need stronger strands. It's more grid-like, truss-like system, but also designed to take all wind and snow load. So this is a structure that is supposed to be there in the botanical garden of Freiburg for 5 to 6 to 8 years. So different, also very different aesthetical architectural appearance. So I think this is my final slide. I think we would never claim that our fiber structures are the solution for all our questions or our challenges that we are facing. But what we want to show is, or what we want to discuss is that we need new paradigms, different paradigms in building construction, and that the research on computational fabrication and design strategies could enable these very different and new building systems. Because engineering science, to come back to this title of optimization, in the current practice of engineering science is 99% of optimizing what is already there, making concrete a bit stronger, a bit more carbon dioxide efficient, a bit lighter, but this at the end, that's what I wanted to say, is not sufficient. We need new paradigms in architecture and building construction. Okay, that was my presentation. Thank you for your attention. And now I'm looking forward to our discussion.
Jan, thanks a lot. It's incredible. It's 10:30 exactly. So thank you very much also for your response. For a lecture, let me ask you one thing, if I understood it correctly. When you showed us the fiber columns in the pavilion, you said one piece is 80 kilos and carries how many tons?
So one piece has a weight of 80 kilos and carries a compression force of 25 tons, 250 kN. So a very good rate of weight to capacity.
Then I understood it correctly and obviously didn't want to believe it. Thank you very much for that.
Yes.
We will now come to a respondence by Clemens Peising, who already is sitting here on the stage and will be talking to you. Clemens is a structural engineer and researcher, and here at the Angewandte he currently heads the digital simulation department, which focuses on the use of computer-aided modeling techniques in the early stages of architectural design. So I'm looking forward to your talk, to your respondents, and I'll be sitting next to you and let's say be a keeper of time and also see if there will be any questions here from the audience. Go ahead.
Yeah, thank you, Mr. Knippers, for this very interesting presentation. And I had the privilege to visit your pavilion at the Biennale a few weeks ago, and I jumped there around a little bit, and it was really very stiff, so very convincing pavilion. And I'm also a structural engineer, and I'm also concerned, of course, with optimization at the office where I'm working. And I think that this pure structural optimization, that engineers are sometimes carried away with their structure. Because actually, the structure is not an end in itself, so the goal of optimization is actually infinite span, zero weight, so to do away with the structure. And but there's a certain limit, of course. So it's only, as you said, possible to optimize maybe 20, 30% away from what you have today. And so I think that when it comes to optimization, there needs to be a holistic approach with multidisciplinary goals set. Because in the end, what we want to have is not a structure, but actually value for the people who use the hardware, so to say. So I think that optimization needs to be guided by architectural goals, by different disciplines, climate and so on. And I think then optimization can do much more than just reduce material, because if you increase the value of the piece, it doesn't matter so much how expensive the material is, because if you want to have concrete which doesn't emit CO2, you have to capture CO2, and the cost of concrete will then be maybe 100% more than we have today. But this is still manageable if we have then more value from the same amount of material. Yeah.
Yeah, I mean, this is 100% correct what you're saying. I mean, I think the most important thing is to use the building stock that we have as long as we can. Yeah, so we have in Stuttgart now all this. Stuttgart is the city of the car industry. You have all these parking lots in the center of the city, plenty of them, and they are now all disassembled because no one needs them anymore after only 25 years of use, 30 years of use. And this is, of course, an ecological disaster, actually, because all this carbon that is stored in the concrete structure is now going to landfill. Yeah, so this is clear that the longest use, aiming for long use of a building structure is the most important architectural goal, I would say. I totally agree on this. But I'm talking here about the new structures that are built from today on. And I think here we have to somehow bring together the two goals of raising productivity. This is something I didn't mention in my presentation, that of course we have to intensify also our building activities, even not only in China or South Asia, also in Central Europe, due to kind of demographical changes and migration. We need more buildings every year, and at the same time use less resources. And this is only possible if we really think of new building systems. That's what I wanted to say. I think our engineering brain, yeah, even I don't question this, yeah. My engineering brain is very much coined towards optimization. Huh? That's a kind of engineering is optimization. I think we have to break this through and really look for new disruptive innovations, as to use this kind of current buzzword that you can hear everywhere. And I think this is something that we have to be aware of. And this is what I wanted to show.
Yeah, I think also that engineers are geared towards complexity reduction. They are faced with a problem and they want to break it down into simple things. And in the field of architecture, it's maybe a little bit differently, because there the problems are much more complex, because you have conflicting goals. So it's not easy to optimize it, because in a multi-objective optimization, there's never one best answer, but there are many. So this may be also one reason why this pure engineering optimization leads to less versatility, and in the end, after the lifetime of the structure, leads to costs which are much higher than we would have cost for a not so much optimized structure. What I really think is that this value creation needs to be the optimization goal and not the structure, in my opinion. And the title is actually optimization versus versatility, but actually it should be the question how to optimize versatility, which is a very hard question to solve. And it's not something which can be solved by one discipline, and therefore I think this multidisciplinarity is, we need this, and this will be, I think, the disrupting step, in my opinion.
Yes, I mean, I agree. I don't want to claim that what we are doing here is the answer to our questions. That's not the. We would never claim this. And I think, in particular, Vienna is a wonderful example of your 19th century buildings that are far away from being optimal in terms of energy consumption or anything, but they're still very, very very but they create a value, and that's why they are used for centuries. And this is, of course, also from an ecological perspective, the most important aspect, that people use the buildings for a long time.
Jan, if I may interrupt shortly. As far as I understood your lecture, I would say that, or at least it makes the impression that Jan Knippers is 100% Mr. Optimization. If I would assume that there might also be a little bit amount of Mr. Versatility, how many percent would it be in your soul?
Yeah, I would no. I think then, but then I have to say I wasn't successful to convey my message, actually, because I don't see myself as an optimizer. I think leaving the path of optimization, of kind of unidirectional optimization, that is important, and thinking about new technologies. This is what I wanted to communicate with my lecture. Yeah. And and versatility is maybe versatility is more an architectural question than a kind of scientific or engineering question. That's where the two domains meet, and where it becomes interesting and challenging at the same time.
Thank you. Before I hand over to you again, Clemens, just one question to the audience. Is there any question from you to either Jan or to Clemens that you would like to raise? Karin, what about microphones? Do we have microphones in the audience? Yeah, perfect.
Thanks. Yeah, Jan, you showed a very interesting graphic where we could see that not only the production of CO2 produces a lot of, the production of cement produces a lot of CO2 emissions, but also the production of the machinery. Mm-hmm. So my question is, does it also go into your calculation? For these fascinating new techniques, you need a lot of robots and, I don't know, production lines and so on. Is this also calculated as a factor for the overall amount of CO2 emissions that come out from such an experimental pavilion, and not only the material and the energy that actually goes into the production?
Yeah, that's a very important question. I think that's also what we wanted to show, that we as architects and engineers have to develop our own production processes and cannot depend on or rely on some experts from some other fields that bring them to us. There's this narrative of this high-tech architects like Norman Foster and others that always tell the stories. You just have to look at the aircraft industry or the yacht industry and look what they are doing and transfer their processes to architecture, and this will push us a step forward. But this is, in particular, as the fiber composites show, not the case. As I said, for a windmill, or the blades of the windmills are made from fiber composites. They have the mold, and the mold is made out of polyurethane foam. From an ecological perspective, a very problematic material. This is all waste going away. If you produce 100 windmill blades, it's fine. But if you produce one component for your dome, it's not okay. That's why we as architects and structural engineers have to develop our own construction processes that take into account the specific conditions of our domain. And this is part of the whole story, that the development of fabrication processes and design methods have to go hand in hand together, and only this enables the kind of progress that we need to address these challenges.
Let me just check if there is one more question in the audience, one more, and then Clemens, I'll hand over to you again.
Yeah, this is Walter Meyerhofer from FH Wien, formerly also with the Urban Strategies program here at the Angewandte. One question.
Maybe you could shortly just remove your mask while you're talking.
Sorry. One question that is just an extension of the previous question is, wouldn't it be also necessary to look at the lightweight structure here? I'm thinking about thermal mass, and if you're talking about a CO2 measurement, wouldn't that need to be a life cycle evaluation? And if I look at the lightweight structure, in order to create a livable space, you would need a lot of machinery here in order to heat it and cool it in the summer. So, and I'm sure you thought about that.
Yes, I mean, this is also a very good question, but from someone who is at home in the academic world as me, I know that for 25 years, research had a very strong focus on the energy consumption during the use of the building, and no one looked at the emissions or the energy that is used for the actual construction of the building. And I think we have strategies to address a kind of greenhouse gas neutral use of buildings. Also, as you can see, mass can be added also by other means, by mineral components that can be removed later, which are not made from concrete. So there should be strategies, but now the focus that we have the strategies for an energy neutral use of the buildings, the focus has to shift now to the erection and construction of the building core. And that's why I think this is in the focus of our research at the moment. But of course, I'm fully aware that something that you can see here on the top, on the bottom right, Maison Fibre is not something that you can use as it is, as a kind of regular building. We have to provide additional layers that provide the thermal mass for use of the building.
Okay. I have also one question, maybe. The reuse of materials in building projects. I think that this is a very difficult topic for several reasons, because for one thing, normally the pieces are very heavy, so to place them somewhere else is normally only very difficult. And then the other thing is that sometimes it's not known how the part was actually built. So in many buildings of the 1950s, 60s, 70s, there's no information available anymore what kind of reinforcement is inside and so on. So I think this is also a barrier which needs to be mastered. I mean, at the moment there's this BIM modeling, which will probably be a good thing in the future, but basically reuse of components is, I think, very difficult. And also the fact that you have to join the components somehow. I mean, also in your pavilion, you have to join the pieces somehow, and this is often more difficult than to design the pieces actually. So.
That's true. Yeah. I mean, this is from a structural engineering perspective. That's the main challenge. That you have this very high forces in the carbon fibers, and you have to connect them to the next component. And this is from a structural engineering perspective the main challenge to design the joints between these two components. And as you're right, I mean, this idea of reusing building components is a very old idea, but it goes back to, I don't know when, to the first ideas or attempts of industrial production of buildings in the early 20th century. But to my knowledge, it actually never really worked out, because you have this many challenges that you just mentioned. That's why we have to, I think the right way would be to find, to develop building structures that you can disassemble, and where you can also divide the sources of the materials, and then to reuse the materials or recycle the materials or reuse materials or use the materials as materials, but not as components on the material level, but not on the component level.
Yeah, solution would be maybe to have some kind of Lego system, but then it's also the problem of uniformity maybe. Yeah. I mean, if you look at the cities in China, for example, where you have these high rises, these dwelling high rises, they're so uniform, so they're very much optimized. But I think in the end, it would be maybe better to make them not so uniform, because then it would be maybe more livable, and in the end, more productive there. So, yeah.
May I add one more question to you, Jan? You showed us different projects, and most of them had artificial materials, like the fibers. And the last pavilion in Freiburg had hemp and flax. And you showed us also on the Excel sheet that the theoretical strength is quite similar between flax and glass fiber. But as you also mentioned, there was a difference in the construction itself, because obviously with a natural ecological material, you cannot build that efficiently. Can you tell us a little bit about the loss of efficiency when you build with natural materials?
Yeah, I mean the challenges when you use this bio fibers is first that you have a larger deviation of the mechanical properties. And the main difference to these synthetic fibers is that the natural fibers have a limited length. So they are 5 to 6 centimeters long, and they form then these rovings. But when you tear these rovings in a state where they're not impregnated with resin, you just can pull them away, tear them. And that's why that makes the fabrication process more challenging, and that's why you have this thicker strands. But on the other hand, if you look at it from a carbon dioxide perspective, if you have a thicker structure, it means that you store more carbon in the building structure. So from a purely ecological perspective, it's not worse to have this thicker strands. For a carbon structure, the thinner the better. But for the flux structure, if the strands are thicker, you store more carbon dioxide in the building structure itself. So that's a different way of looking at the idea of lightness or efficiency.
Thank you very much. Thank you also, Clemens, for your respondents. Clemens, one final question to you before we go into the break. The title of this symposium is Optimization or Versatility. You mentioned it already a little bit in your comments and in your response. How would you give an answer on that question?
Whether the two are opposite or can be joined together, maybe. I think if you have more advanced techniques of optimization, it's a technique. It's possible to include different perspectives, not only the structural ones, into an optimization. And it's maybe also about flexibility, because nowadays still the buildings are to a certain degree determined by what we can analyze, what we can compute. And if these limits go away, maybe with faster computers, then also these limitations will be raised, and then it will be a more fuller optimization. And but as I said, in a multi-objective optimization, there are always different optima, and there needs to be someone who chooses the right solution, and this will still be a human being, of course. So there's still room for design decisions, also with very smart computers.
Thank you very much. So thank you, Clemens. Also thank you, Jan, for your input. We'll now have a short break, and we'll continue in 10 minutes with some small inputs, some shorter speeches to the topic ideas and tools for a circular building culture. See you back in 10 minutes.
Thank you.
Now have 5 shorter inputs, and we'll start with the first one, Renaud Haerlingen from Rotor in Brussels. Renaud Haerlingen is an architect, member of Rotor and co-founder of Rotor Deconstruction. He has taught at the RCA London and was visiting professor at Social Design at the Angewandte. Rotor Deconstruction is a spin-off of Rotor and is active in deconstruction projects organizing the dismantling and sale of building parts for reuse. And today, Renaud is talking to us about supermatic observations on the reuse of ceramic tiles. Renaud, go ahead.
Hi, hello. Yes, I will speak about the tiles, but I want to go further from there. Today the invitation is with the title with circular economy, and there is this architecture of emergency. And 2 or 3 years ago, we were invited in London for a presentation at the Barbican, and the poster was this image, quite dramatic, and we replied claiming that this felt like a more inspiring poster of something radical, maybe. Because what we see here are ceramic tiles that have been reused and put into a publicly funded project through a tendering process. So for those tiles to be there, it means that they have been reclaimed in an existing building. And for those tiles to be reclaimed, it means that the decision to take them was taken in a space that had graffiti and dust, and the assessment to say it's worth going for that was done in a place where not many decisions are made today, it seems. Also, when you start to collect those materials, you don't have a material that is ready to use. You still have plenty of edge of cement, so you need to bring them to a place and go through a process. We do that at Rotor deconstruction. We drop them in acetic acid, which is kind of vinegar. It dissolves the cement, and then with a high pressure wash, you start to have a product. And then that's interesting. When you start to have the product, you can look at it closely, and you can see the name, the brand. It's a model. It's also something that comes with its own history. It was a kind of tiles that had its own cultural impact. And they've been commissioned by an architect and tendered and put into a multi-apartment building, which is something that feels like a challenge. And this is the work Rotor is doing, and it's kind of some core of the circular economy in the construction sector. But at the same time, I want to highlight that the group of people that we are, when we do design commission, very often we end up with solution and proposition that don't rely so much on reused material. So maybe the consideration for reused material and for materiality also inspired and fed our thinking and our architectural thinking to come with other architectural way of doing projects. And so I would invite you to look at those kind of projects in the portfolio of Rotor, where the relation to materials would maybe surprise you. But today I wanted to invite myself in the conversation of the optimization, versatility, with a work that we did here in Vienna in 2017. And it was an exploration, a 2-week workshop for the Freimit. So basically the idea is that at the Nordbahnhof, there was a new master plan, and the idea of the master plan was to keep an area in wild, because it was full of quality for the architect and for the community living the place. And what was already there would be the quality of the space. And that felt something to be challenged, and not, they won the competition, so the idea passed, but it was something not easy or not comfortable for the responsible, I guess. So we came there, and we started, they kind of asked us, could you explore the material value that is in this wild and reveal it? So we did our homework. We start to reveal, oh, there was an old self-made skate park. Let's clean it and show it. And we made that for a series of there was an historical bridge. So we found the story of the bridge. We trimmed the trees so that we could do a nice picture and reveal the value. And we did that for a kind of stairs that gave access. So you could start to see there is an organization of the space. It just required that we took care of it for a few hours or a few days. We made it for the playground and the skate park. We also start to see the people on the site, and there are like people cultivating ants, because it was a train station. There was many trains that came, so there is a very rich biotope, and also for lizards there were installations. So we reveal of that. But actually, the elephant in the room when we were doing this work, from an environmental perspective, was not so much the very beautiful things that we could reveal. It was that all around you had urban development that is kind of a very big one at the scale of Europe, and what they do is this tabula rasa approach. So we know exactly what they will do and how they proceed. And we were not talking about that. It was just across the space. But so we did the Rotor thing. We started to go around in Austria, everywhere, over the 2 weeks, and start to meet the people who trade reused material. And we selected the guys who could deliver materials that could be put in those specific typology of construction. And so we found bricks, we found cobblestone, we found tiles, we found old wood, we found example of applications. And it felt like more important to say that, or as much important, more important, I think. So the design project that we made, we decided to put on the site a white line on the construction line, the zoning law, about what would be kept from the master plan and what would be left, what would be saved, what would be lost. And so we made the line on one-to-one so that you could start to see what we keep, what we don't keep in this logic, and start to have a material and one-to-one, down-to-earth feeling of that, about that. Of course, we knew where to cut when we needed to cut, the side that they will lose. On the side that they will keep, we respected that it will be kept. And the line was done like this. And the final of the commissioner of the workshop has been to set up an exhibition with what was in situ, but what was ex situ, and could fit the situation in its role, and presenting posters with the companies that could trade materials to the construction all around, and with the sample of each of the materials. And quite important for the discussion at the time, we also asked an engineer from Innsbruck to come and encode them in the BIM system, because it was kind of the idea that these new buildings in this master plan are super optimized in the way they unfold, they are fast, efficient, and reused material don't fit in BIM. So that's a problem. And that felt like a non-problem. So the guy came, put them in the BIM, and so they were just next to them. And we invited the people to come and to see by themselves. And now, if I'm stealing a few more minutes, because I just want to do it, the next step, or kind of parallel step, is a work that was also done with the student of the Angewand and the social design faculty. The group of students start to be tired of all the greenwashing and the circular labeling of many things, but it was very often in between the line about keeping the statu quo. And so they said a few people seem to be gentle, genuine, they want to change. A lot of noise is done. Can we start to be closer to those people who want change, who are welcoming that it will provoke change? And so we used the method of the cahier de doléances, which is before the French Revolution, the kings asked everyone in France to write their problems or write their ideas. It was just too late, the revolution happened, but the idea has been to meet the group of people that will be involved around Nordbahnhof and Franz Josef train station for the next 5 years. We know precisely there will be big transformation, 2 big projects. There are specific people that will be around those work for many years. And they said, let's meet them and let's hear from them what could be things that could change. And so there is a kind of family of people that turn around, and it was interesting to reveal them. So there are material resellers who trade materials that could be reused in those kind of operations, which seems to be not obvious or not easy. There was the influencer and the policymakers that were around the project, and now there was the developers. It was interesting to meet them, the contractors that would be built or suspected to build those sites, the architects, and the pioneers, the people who have done some relevant things in Geneva. And it happened that they gathered them together. And it's interesting to see when you look at the photo that each family has maybe their own language, their own code, their own working environment. They are a little bit in different worlds. And that was something that we wanted to explore and to see, because there is this feeling that it's not so much of rocket science, but there is a kind of complexity. And maybe it could find a starting point in many pieces of the game and start to see the direction. Okay, that was my contribution to the conversation.
Renaud, thanks a lot. We'll be having questions to you in the discussion. Next impulse is Gwyllim Jahn. Gwyllim, are you with us already?
Hi, hopefully you can hear me.
Hi, what time is it now in Melbourne?
I've fled plague-infested Melbourne. I'm in Perth at the moment, so it's 5 p.m. It's very, very comfortable. It's just turned 1 o'clock.
5 p.m. That's not even that bad. So good.
No, that's fine.
Good late afternoon. Hi. Gwyllim is lecturer at the RMIT University at the Royal Melbourne Institute of Technology and the co-founder of Fologram, a Melbourne-based design research practice and technology startup engaged in building a platform for designing and making in mixed reality. And Gwyllim will talk to us and present different projects built in mixed reality from non-standard materials. Looking very much forward to hear what non-standard materials are. Gwyllim, the stage is yours.
Thank you very much. So I'll show 5 different projects completed by Fologram or our clients that are intended to illustrate new ways of working with often overlooked materials and to try to demonstrate their potential for design. And I think for the purposes of this symposium, we can treat these 5 projects as almost like provocations. I think they're not necessarily trying to propose a better way of constructing than we currently do, but merely a fairly radically alternative way to thinking about this process of materializing design. So this object on the left or on the right, this is a sort of a complex 3-dimensional shape that is very easy to generate with contemporary CAD software. And if I was to ask people in the audience how they might go about building an object like this, perhaps you would suggest laser cutting its contours or splitting it in half and CNC milling 2 parts. You know, it's a complex digital object. We typically use digital tools to machine these kinds of objects. But these processes are typically quite slow, involve generating a lot of waste and all or nothing. They can fabricate these objects precisely, but if you make any mistakes in assembling or programming the machines, you typically end up with no result at all. Now, this short video here, hopefully it streams okay over the internet, is of the first project that we ever did using the HoloLens to try to build a digital model like the one which you saw in the previous slide. This blobby little surface, we fabricated it back in 2017. And the way that we did this is by using that 3-dimensional design model as a sort of a constant holographic reference, which would show us how to place these little river pebbles, which is an example of a non-standard material, to fabricate this curving geometry. And the point here is to, I think, encourage a rethinking of the idea and necessity of precision in fabrication. So in placing all of these river pebbles with the HoloLens, what we were able to do was to very approximately and very, very quickly capture a representation of that digital model. And that represents, I think, a fundamental shift from the all or nothing approach of contemporary sort of design to production, computer-aided manufacturing. I think it means that perhaps we can think about a sort of a new way of fabricating three-dimensional designs, which lies somewhere between entirely analog processes like traditional sculpting and entirely automated processes like robotic design. It means that perhaps we can produce wildly complex forms cheaply, quickly, but approximately. And I think it then leads to a question of whether or not this lack of precision is desirable, because these prototypes, when you build them approximately, they can be pretty ugly. It certainly means that we need to re-question also our aesthetics. Using the same approach of having holographic models as kind of constant reference points and guides during fabrication and construction, we've also tried to create more beautiful objects, dealing with this exact question of aesthetics in our proposal for the 2019 Italian Architecture Biennale installation competition, with a theme of beauty matters. And this pavilion, the reason I show this, just a little glimpse of this project, was constructed entirely by hand from 12-meter long lengths of steam bent timber. And this is a very flexible material that, even though we had a hologram showing us exactly the shape that we needed to bend these pieces of timber into, inevitably that material would slump and deform under its own weight, and the entire structure would also slump and deform slightly. And so rather than over-engineering the materials, which is what typically happens, if you've got a material which is slumping under its own weight, you would re-engineer the structure, perhaps use thicker materials to prevent that from happening. What we decided to do was instead embrace this material behavior of the weak and flexible materials and simply re-digitize or redraw the structure while we were building it in order to constantly accommodate for this movement in materials. And again, just like with fabricating things from river pebbles, this approach to digitizing existing structures using the HoloLens, which you see here, this is Sean remodeling a strip of timber just by tracking this, it's basically the back of our business card, and using the position of that card to loft a new surface. This is also a very fast, approximate, rough way of digitizing existing geometries, which I think is a fairly radically new alternative way of creating digital twins compared to alternative technologies like 3D scanning, which are typically very, very slow and very, very expensive, but also very precise. Another example of working with mixed reality to improve the feasibility of flexible materials is a project that we worked on in Hong Kong. And this project features a kind of, or continues this lineage of fabrication approaches with very, very short production chains. So in this case, trying to make a complex double curved surface just from standardized lengths of bamboo. And the holographic model, like building in mixed reality in this case, provides a constant reference not only to the overall shape of each part, but also the length and location of the individual strips, the topology of their joints, and the exact assembly sequence of the model, which allows teams of fabricators to build these wildly complex structures in parallel, rather than this typically being something which can only be done by experts. And this democratization of access to technology and sort of these new ways of making, I think, is a sort of a critically important feature of working in mixed reality. This little project I show because it's an interesting use of recycled material. In this case, I think most people would look at these piles of steel and just, put them straight in the waste heap. But the University of Tehran came up with a workshop which could repurpose this, waste steel pipe into a structure that was designed entirely digitally. And without access to a HoloLens, participants in the workshop instead used their mobile phones and mobile augmented reality as a guide to show them, again, how to fabricate each one of these 2D parts in the structure following an augmented reality model viewed on the phone, and also how to assemble those parts together. So I think it's kind of interesting that the accessibility of this augmented reality model to anyone with a smartphone can fairly radically improve participation and understanding of the design model, and also accelerate this learning process and collaboration between novices and experts. In this case, the experts being the people who have an intimate understanding of the parametric modeling software. The last project that I'll show is by a client of ours in Japan. And in this project, holographic models enabled the use of handheld machinery, chainsaws and power drills, to cut and assemble unprocessed timber into a reciprocal structure for a piece of furniture. A 3D scan of each log allowed the design of booleaned joints to be generated digitally and cut by hand, something that would have been challenging to do ad hoc, or made up on the fly without a digital model at this scale. And this project, I think, serves as, again, a sort of interesting counterpoint to research being undertaken mostly in Europe, actually, which is utilizing 6-axis milling to create joints between unprocessed or non-standard lengths of timber. In this case, the result, like all of the projects that I've shown so far, is still approximate. If you look carefully in the kind of the finished fabricated model, I'll skip forward a little bit. Even though the cuts are perfectly flat when this structure is assembled, just the slight deviation in following the holograms showing these cuts ends up with not perfectly horizontal surfaces for the furniture. But it's realized at very low cost and high speed, and with a very high degree of adaptability in the process. So making changes during fabrication, if you're working with a robot to mill these joints, would be extremely difficult. You'd need to move large parts to a different work area, need to recalibrate robot and part, and potentially even retool the robot if any changes needed to be made during assembly. Whereas when you're working from these mixed reality models, there's huge advantages in that you're able to adapt and make changes on the fly, even when working with these sort of unpredictable materials. And this can significantly reduce the risk of very ambitious design without, introducing the possibility of a cumulative error or complete failure during assembly. Okay, I think that's my time. Thanks very much.
Gwyllim, thanks a lot. We will now switch over from an approach of approximity to an approach of precision. The next speaker is Erich Kotroczo from SITE, a SITE studio for information design and specialized in BIM. And Erich will be talking to us about the power of BIM for circular strategies.
Great. Thank you for the invitation. I'm Erich, founder of SITE. We are a group of 10 digital natives with an architectural background, located in Vienna and Munich. We help stakeholders in the whole building and planning industry in the field of digitalization. So we basically show them contemporary tools and how to use them efficiently and maybe change processes inside of their project. For this, we mainly use BIM as our key technology or key tool. And just for an understanding, like how we understand BIM, Building Information Model, this is basically a model. It's from Pichler und Hauptmann Architekten. I think Hannes, few of you guys know. It's the ÖMTC headquarters located in Vienna, and this is what you see now is basically the one of the most important things in a model, the geometry. But what makes this model to a building information model is the information behind the elements. So basically, if you have a screw, just very simply said, you have a screw. The screw is located somewhere in the model, and the screw has properties, attributes, like in which direction do you need to screw it in, left or right hand, for example. And also the torque, like how hard do you need to fit the screw, basically. And if you have all this information, you can imagine you have robots that place this element on the correct place and stuff like that. So basically, that's the starting point of every following simulation and automation that we try to achieve in the near future. And around 2 years ago, we started a research project together with a few institutes of the Technical University of Vienna and Matthias Mitteregger, where the idea was to take a look at the materials that are flowing into the building industry, and after demolishing, renovating. Right now, a lot of this material is basically waste. So it's just a very little portion is recycled. And with our research project, we tried to take a closer look at the process, like what is happening, to analyze the buildings, analyze the materials, like how could we make this process a little bit better and maybe develop some tools for that. So our starting point was to take a look at the building stock in Vienna. So you're focused on Vienna. So there is, of course, quite a huge building stock with unknown material resource. And 48 million tons of waste is yearly produced in Austria, which is the equivalent of around 70% of the waste in total, which is generated in Austria, which is hideous. That's bad. And Vienna is working on that. It plans in the smart city strategy. It already plans to reuse around 80% of the materials that come from demolished or renovated buildings in 2050, which is quite far, but still a goal. In the research project, we first of all tried to analyze buildings and the materials. Of course, we couldn't take all the buildings in consideration. We picked out around 200 building blocks, so it's not buildings itself, but building blocks, to create a database, which we interpolated into a bigger database. We then tried to develop explorative scenarios and asked ourselves, like, what could we do to optimize the process? And the guys at the Technical University created a simulation model with a tool, with a prototype. I will show it on the next slide. And our focus was then on the building information model. Like, how could we take care of the material information inside of the models, maybe in the new project, but also in the buildings that we already have. And then we analyzed the process and worked out a little process, like how we can do that a little bit better. The result was this prototype. It's a visualization and simulation tool connected to the database that we just put together. And as you can see, this is a very rough estimation because we took only 200 buildings in whole Vienna. And I think there are around 400,000 or something like that. So it's really just a really rough estimation, like where to find which kind of materials in which district and on which building block. But now, basically, there is a technology around the corner. We heard a little bit about that today, so building information model. And I told you before about the parameters in the element. So every element you click in a model has parameters, has attributes. And one of these parameters or attributes is material. So if you click on a door, the door frame, for example, has a material which could be wood, I don't know, cherry wood, something like that. And every material also has parameters. So this can be parameters like thermal parameters or physical parameters, but also like CO2 footprints, for example. So this is happening right now. So everybody that creates models, I really encourage to take care of your materials, because you're right now creating a database for the future that people, machines can read out and simulate with these materials. So what we basically do is we updated our material library, that every client of us gets this material library, and every time they place something in their models, the material information in the background is of course already correct, with also the CO2 footprints and so on. So basically that's not a lot of work. I really encourage you to do that. It will help the future quite a lot. This approach is of course only applicable for new buildings, but what we also try to do is for buildings that are renovated, we take point clouds. So basically we go through a building. It doesn't take that long anymore. We basically have this LiDAR system where you have one button on the machine, you click on it, and you can see on the right top picture, Asra is just walking through the building and it takes a point cloud. So it's really kind of, I think that's 20,000 square meters. You take, I don't know, half a day to walk through the whole building, and that's basically it. Then you have the point cloud. And right now, at the moment, we built a building information model out of this point cloud. So we place walls, doors, etc. But in the background, the materials are already applied to these elements. So basically, for these buildings that are already reality, we also get the information, of course, if we have the material information in a model, so we can work with that, we can simulate with that. And in the near future, there will be systems that can create building information models out of the point clouds. So the conclusion is basically the combination of generalized data is necessary with real data from building information models, and this will take a long, long time, because we will have a lot of buildings that are around us and they are not new, so we will take a long time to work with statistical data on the materials of buildings. What would really help is a digital, is a rule set for the digital submission. So that's what especially Vienna is working on. And you really need to take care of your models. So basically take care of your materials in your models. There's also a little bit working on the technology. For example, IFC 2x3 doesn't support material properties, so you need to use IFC4, but that's just a technical, yeah. Thank you very much. That's basically it. Yeah, hope you enjoyed it.
Erich, thanks a lot. We will now continue with digital input. Anupama, can you hear us?
Can you hear me now?
Yes, we can hear you and we can see you. Perfect. Let me just introduce you shortly. Anupama Kundoo. She's an architect based in Berlin, Germany, and in Pune, India. She's specialized in people-centric architecture based on special and material research for low environmental impact. She's currently professor at the Potsdam School of Architecture in Germany, and she very recently received the 2021 Rebbe Charles Jenks Award. Anupama, what you will be telling us is, among others, presenting a project, a temporary pavilion in Barcelona, which, to quote Gwyllim, is made of a very non-standard building material. Anupama, the floor is yours.
Thank you. So I'm just, because I'm aware of the work of some of the speakers here, and I thought instead of getting into all the theory behind that, I would just show some projects in a different context that I made by upcycling waste, because I think that architecture can be the mechanism for permanent capture of urban waste. So I'm going to show you just a couple of projects that have focused on the direct reuse of waste, because I've seen, especially in developed countries, that the materials that are being produced are very difficult to dismantle, and there are many mixed materials, and it's very difficult to recycle, often without using more energy and more processes and so on. So I have been I put together some of the things that you can use without doing anything directly, as if it were like you use natural materials, you know. So one of the first projects I did was, in fact, when I was a professor teaching in University of Queensland at that point, and I was asked to build a pavilion in Barcelona among some architects who were invited there, and I started working with books, because I realized that among the unconventional materials that you find in huge quantities all over the world, books sadly are one of them. And in Australia they got pulped, and in Spain they got burnt, and so on. So I started exploring with my students, what can we do with books if we don't if we demystify them as their original purpose. And with, I mean, it's a source of, on one hand, books are getting obsolete. On the other hand, there's overproduction also, magazines and things that are for temporary use. So I had collaborated with IAC in the Institute of Advanced Architecture in Catalonia to be able to produce architecture using this material. And I've been thinking that especially for temporary projects and pavilions, let's try to avoid buying anything and extend the life of existing materials. So, you know, students were discovering properties of books just as if you would discover the properties of any other material and see its suitability for architecture. So we discovered various things, and we produced a palette of applications. But two of the interesting things that we have built then later are with books and magazines. We've through folding and stiffening, we've managed to create furniture. This is exhibited once, these book sofas in Madrid. And then we, for the pavilion in Barcelona, what we did is we realized that the books, if you force open them and vacuum pack them to stiffen them, actually the idea of vacuum packing came also because I was looking for vernacular technologies in Spain, and that this is a household machine that is used for taking the air out of food packaging. Mostly you see all the olives and ham that is part of the local culture that has been, so it's a very, very handy machine which you can operate, you can use. So it's a very friendly technology actually, if you were to call it a technology. We stiffen the book surface by make the book rigid by using that vacuum thing, at the same time making it waterproof. And then we developed patterns for producing canopies, and eventually we made this pavilion. So we wanted to show the city on one hand, make them confront the kind of waste that they produce and don't look at. On the other hand, it was called the Library of Lost Books. And there's no time to explain why we did this kind of an art installation. But I think that the theme that was given was liberty, and I wanted to say that knowledge makes you free, and somehow use the books. You know, we're focusing on knowledge and consciousness, but also the fact that these objects are becoming obsolete, and there are new knowledge is going to find new form for the future. So this is just one of the projects. You see the sofas, the units of furniture were also used here. Everything is made out of books. Then these are other materials that are very difficult to dismantle. Like Tetra Pak is a problematic material because there's plastic layer, there's aluminium, paper. It's so much work to separate all these layers. But what we did is, in an installation in Mexico City, we decided to reuse those Tetra Pak as is, because it's such a sophisticated waterproof material that we filled water or sand, etc. And we decided the best thing to do is to reuse it as a brick. The simplest thing to directly reuse it is as a brick. So we made some structures with Tetra Pak. That's one example, for in the public space. These are also done for with students because we are trying to allow students to have a one-to-one experience of translating architecture from concept to reality in a matter of days, and confronting many things, not just the waste, but also a physical site, geometry, and going from the drawing board to the one-to-one. So similarly, we have sometimes used in installations where you have to do an opening. For example, in the Hay Festival in Segovia, we had to distribute drinking water. The topic was water and in the age of climate change. So we used the drinking water to create an installation instead of stacking them in crates. And as we distributed these bottles, they got spread and the installation dismantled. So these are just opportunities for architecture students to be able to deal with unconventional material, so that when they go back, look at conventional material, you even a simple brick can be seen with new eyes. I just want to show you some examples, okay, of work. So even when it came to real architecture, and I'm researching many other unconventional materials, this is ferrocement that we are producing modular housing with. It has been displayed in the Venice Architecture Biennale 2016. But even when we produce materials for installations and exhibitions, already, except for 6 elements, all the rest was constructed from the previous Architecture Biennale, sourcing their waste, producing objects, recycling them, and then after this exhibition was done in 4 months, we gave it a third life by dismantling these various pieces and making other architecture out of it after the exhibition. So here you see a ferrocement home and a ferrocement toilet that was exhibited. So the home became reassembled as with architecture students and refugees in the area of Venice, Marghera. This has been become a facility, additional kitchen and infrastructure for an existing community initiative for housing refugees. So and the toilet unit was then recycled. It came to Berlin for another exhibition, and after the exhibition was done, it has been become an information pavilion. But this was also constructed with students along with other scrap material, all sourced from the junkyards, all kinds of materials producing architecture. Sometimes I've used also cartons that you have now, especially after COVID. But this was an idea I was already working on. Now after COVID, I have many more materials. So I've been using materials also for form work. So this is cartons that can form the form work. You see, this was also in University of Queensland. When I was teaching there, we produced this origami type fold form work on which you could cast very light ferrocement. So formwork is a very expensive matter, and that is also something that can be done with waste material, and that's the resulting architecture. And finally, I'll just show you this is the same form that we are using now for recycling denim. We are using waste denim that comes out of, actually they are not even waste, they are the rests of all the jeans that are made in India to export to the rest of the world. So all these heaps of denim get left behind, and we are exploring some kind of tent structures for that. So these are some of the things. I'll just show you 1 or 2 images that even in the making of normal architecture products that I'm custom making for roof technologies, even you see that they are the coconut shells. It's a kind of waste, that bio waste that is being used as fuel to produce this kind of housing. So the scope for using so-called waste material is multifold, from formwork to material manufacture as well as direct reuse. In this case, where we are firing large-scale earth mud houses to make this house into ceramic, we have used coal dust as a fuel. We've swept the floors of, you know, when industrial kilns have some still calorific value in the coal dust. So that 5% of that coal dust has been gathered and mixed into the brick and then used to fire entire mud houses to make them into brick. So it's called baked in situ earth construction. And even the formwork of those windows, etc., were made by taking bicycle wheels and other unexpected products to form this kind of construction. And the bricks can later be sold and economy can be generated. So houses can become producers of building material rather than consumers. And the house itself was finished also with broken tiles, waterproofing as final waterproofing. And the toilet units were made with recycled bottles, and the tips were made with broken chai cups. So here you see the Venice Architecture Biennale in 2012 has also been made using, you can see the conventional roof in the background of terracotta, but in the foreground you see the same principle made with glass bottles. And with that, I'm going to end my intervention. So these are all kinds of, even though these are direct applications of waste material without further processing, the scope is there from to use it as a building material, but also as formwork, also as a manufacturing process in the case of fuel and other unexpected material as formwork. Thank you.
Thanks a lot, Anupama, for your input and for also showing us what potential there is in waste. We'll be talking about that later. Final impulse now, Johann Fellner. He's been teaching and conducting research at the Institute of Water Quality and Resource Management at the Technical University of Vienna since 2000. Intensively involved in classic waste management processes. And today he wants to ask himself and also us if building and thinking in circular economies and circular strategies and circular loops is really what we want.
Thank you very much for the introduction and for inviting me here to talk. It's nice to see a lot of fancy concepts about circular economy. Why we're talking about circular economy? What is the reason behind that? Yeah, I mean, there are issues like resource consumption, resource scarcity, which are quite important to consider. We need to be aware about that. Yeah, I don't have the time to talk about it, so I would like to skip the first two topics which are here listed. I would like to go directly to the resources in the city to get an idea what do we have in resources there altogether. And we conducted from 2012 to 2020, a very large-scale research project dealing with so-called anthropogenic resources. And one of these anthropogenic resources are materials, construction materials used in buildings and used in infrastructure. And within this study, we went into a lot of buildings in Vienna and assessed which materials are in there, made a classification, and derived quantities on materials in buildings. I don't show the picture. I don't show the results for Vienna now, but I have quite similar results here shown for Switzerland, which has been done a longer time ago, where they found out that basically that is what each Swiss person owns on materials is about 400 tons. So each of us owns about 400 tons used for infrastructure, used for buildings. in Switzerland, it's basically most of it is sand and gravel. Then we have about 20 tons of bricks, steel about 5 to 10 tons, wood, and so on, going down to the different materials. And as I said, we did that also for Vienna. And we determined now, and this is just focusing on the buildings, so leaving infrastructure out of it. So there we came up with a bit smaller number for Vienna. When we talk about buildings, it's about almost 200 tons per person, about 100 tons bricks. So Vienna has a rather old building structure. Then we have about 85 tons of concrete. This is still growing. Bricks are becoming less. 4 tons of wood and about 4 tons of steel, which are used in Vienna buildings. So this is a huge quantity. And when we talk about anthropogenic resources, we know everything what we build basically will become sooner or later waste. So we need to know that this is a potential secondary resource we can use. And some other people did such similar studies on an even bigger scale, not on a city level, but on a global level. And what they found out that when we talk about metals, that today already, for some of the metals, we have extracted in the past and built in our infrastructure, in our cars, in our goods, the quantity of this so-called urban material stocks is already in the same order of magnitude than the materials which are still out there in the Earth's crust. So you see it for copper, it's 300 million tons, which we already use today, yeah, and 600 million tons which are out there. For zinc, it's even today larger than what we already harvested in the past and are using. So basically, why we are not making better use of this material, and then I would say like 10 or 15 years ago, the term urban mining has been created, and this term urban mining has, I would say, switched into circular economy. So even a more stringent dealing with our resources. When we talk now about urban mining and circular economy, I use them here for the same purpose almost, there are several limitations or several problems we need to keep in mind. I tried to put them together into 4 points. The first point is, I showed you now, each Viennese person has about 200 tons of materials, but basically these 200 tons of materials are not available because that would mean that we need to tear down all the buildings. So we have the problem that, or we have the issue that these materials are bound in goods what we need. So we have the in-use stock, and we only are available to harvest materials at the end of the lifetime. So only when a building gets to its end of its lifetime, then we can harvest the materials. So the real potential for recovery is much smaller. But researchers in Sweden found out, and it's basically quite easy to guess, there are also a lot of materials which we don't see in our city, which are below ground. And every time when we upgrade our infrastructure, when we upgrade our electricity grid, it happens that some of the cables are left back in the earth or underground. So this material is not in use anymore, and this would be directly available. So there have been studies done also for Austria, but for Sweden, I would like to stay in Sweden. This is the map from, I think, Norrköping, a city comparable to Klagenfurt, about 100,000 inhabitants. And they really went into very detail and looked where are the copper cables, how much are out there. And what they finally found was that altogether in the city there are almost 3,000 tons of copper below Earth. 2,000 tons of copper cables are still in use, and about 600 or 560 tons are in so-called hibernation. So they are not used because they have been disconnected simply because the grid has been extended and smaller cables have just been left there. The value of those materials is simply, I think the copper price today is about 8,000 euros, so you can easily calculate 500 or 600 tons multiplied by 8,000 euros, so that's a rather huge quantity of money which is buried below ground. And then they investigated how much does it cost to take out the cables, okay? And basically, when they harvest rather small cables, which is able to conduct electricity with 400 volts, it's about, you can get money about 5 to 7 euros per meter. And if you have thicker cables, that goes up to 20 euro, okay? But at the end of the day, to get the cable, you need to dig out the cable and to renew the street. And the cost for doing that is 100 euros per meter. Yeah? So basically, just for going, harvesting the cable doesn't pay off, and no one would invest this money. But what you can do on a city level, you can try to organize different activities which are done in all the cases. I don't know, if there is the road surface renewed, then you can probably combine these two management options, take out the cables, and at the same time renew the surface of the street. And then the cost will be much lower, and then it might pay off. So this is definitely something which you need to consider. The other point what we do face, and this is basically also an issue of the architects and the civil engineers, we do have an increasing complexity in our products. When we look to buildings which have been constructed 100 years ago, we had a few construction materials, very few construction materials, and I show here an example of the elements which are used in printed circuit boards in computers. So in the 1980s, we have 11 elements which have been used, and in the 2000s, so 20 years later, it's not 11 elements, it's 60 elements today, maybe even more. But what does it mean for recycling? What does it mean for waste management? The more materials you do have in, the more complex it gets to be recycled. And the same applies when we talk about buildings or any other stuff, even when we talk about cars. The more complex it gets, the more tricky it gets to be recycled, and that's what we observed. When buildings are torn down, on the left-hand side you see a building in Vienna, both of them down are buildings from Vienna, a building constructed in the at the beginning of the last century, basically bricks, mortar and wood. Very easy to be constructed. On the right-hand side, you do have a building which has been erected in 2003 and demolished in 2013. So just 10 years. And there were a lot of valuable materials in there, but it was almost impossible to separate them. I mean, the picture shows quite easy, quite impressive, the variety of the different materials. So we have the complexity, and the last point, or the last 2 points, we have also a quantitative problem. When we consider the quantities of materials we do need for constructing in Austria, it's about 100 million tons or 110 million tons of so-called construction materials are needed every year. And when we compare that to the quantities of waste arising, to the so-called Baurestmassen, they just amount for about 10% or even less than 10%. So even if we would theoretically could recircle everything, we could just cover 10% of our demand. So this is definitely not what is desired by circular economy, because that means just we can cover a small part of the demand. And the other problem, and this I think is the much more severe problem, which we need to be aware about, is we don't have only a quantitative problem, but also a qualitative problem. Just imagine if we would have implemented circular economy 100 years ago, and we would be able to manage to recycle and reuse all the materials which have been used for constructing 100 years ago. What does that mean? that would mean that today we would still build with bricks and mortar. We would not build with concrete and steel. We would not build with glass. And the question is, I mean, I'm talking to architects now, is that something we would like to have? Would we like to fix the current status and we don't want to go further? This is a very provocative question, but a very important question. So we have a change in materials, and this is not only applicable for construction, but this is applicable for a lot of goods. I mean, when we look to our mobile phones, how they have been constructed 10 years ago and how they are constructed today, there are different materials in there. So if we limit that to the materials which I have used 10 years ago, then we would have not a progress. This is something we need to be aware. I would like to stop already here at this point. I have some conclusions here which doesn't fit to what I was talking because some slides I had to skip. This was just a study what we did when we tried to evaluate what the city of Vienna can really do to increase the circularity. Unfortunately, time is not enough to talk about that, but there were some ideas which we collected. Thank you very much.
Johann, thanks a lot. We are running out of time a little bit, but still we want to give you a 10-minute break. So Gwyllim and Anupama, you're joining us online. Is it okay for you now? So we will do a 10-minute break and start at whatever time it is at your place. 20. We'll start at 20 past.
Mm-hmm.
Anupama, okay. Gwyllim?
Yes.
Sounds
okay,
good.
I'm here.
Thanks.
Okay, perfect. So see you in 10 minutes. Go and get a coffee or a glass of wine and talk to you soon. Thank you. So you at home. I'll ask Renaud, Erich and Johann to join us here on the stage. And also welcome back again Anupama and Gwyllim. Let's start. We had a certain choreography. We'll start now with the last one and go to the first one in the end to Renaud. And my question to Johann, who was talking to us in the end, what did you learn from the others? I have to ask because I had the impression that some of you, of course, were also a little bit contra to each other. It was precision versus approximity. It was waste use and the question of what waste can we really use. So you had different positions. And Johann, I would like to know from you, what did you learn? And maybe also what oppositions did inspire you?
Yeah, I think it's quite good to have different angles on the problem and different views on the problem. And what I definitely learned that there is a lot of creativity for different solutions. But I think we need to be aware that these solutions will not solve the whole problem. Maybe they will contribute to tiny issues. They will arise better awareness. They will arise better awareness regarding how to design buildings and probably also how to better make reuse of them at their end of the life. But it is very important to have the whole picture in mind, and that's probably the reason why I tried to make stress at the final end that this should be considered as well. Yeah.
Thank you. Anupama, what did you learn from the others, maybe also from oppositions?
I would just say that I think what we have in common is the same goal and purpose, but the way, because of the different contexts and the areas of expertise that each of us have, I've been following the work of others too. you know, I think it's just a way of complementing and sort of bringing a wider spectrum to what is possible. And for example, I have seen the work of Rotor, and we have interacted on other platforms as well. And you know, based on each context, I've been observing more the context in which these projects were conducted, and therefore what learning it brought, so that we don't have to reinvent the wheel. For example, in the case of Rotor, they have to face the question of how to economically sustain certain unconventional steps of labor involved in extracting material or sourcing it from the waste area. And then by Gwyllim, we have seen, you know, also the in a context of where everything is not produced by hand, then how do you go digital to that point to handle irregular materials and things like that. So in my context, those similar things have been handled through a different process due to my context. So it's always interesting to keep connected with others' experiments and to get a holistic view on it.
Thank you. Erich.
Yeah, I think it's always, you need to find a balance between the coarse and the fine view of the things. And I think especially for people who work in models, they always have this problem. So basically your environment are just buildings or volumes around you, and you work on a detail on your window, for example. So you're always in these two worlds of really rough elements and also like really detailed elements. And I think like in everything, you need to find a balance in between. Like, yeah, how to use that.
Thank you, Erich. So Gwyllim, I would like to continue with you.
Yeah, I appreciated the contraposition of the last talk, because I think it reveals that if you want to bring about any kind of change in the status quo, there needs to be sufficient incentives to do so. And so in our practice, the incentive for working with waste materials or non-standard materials or enabling others to do so is to facilitate a higher design goal. So there's kind of a inherent bias towards making particular kinds of buildings that we already wanted to pursue, and then that was facilitated through these technologies. And I think I've seen that pattern of incentives repeating itself through all of the talks, whether that's an economic incentive or a community incentive or I think in Anupama's work, there's maybe a combination of those two and our own interest in just particular kind of form makings and participatory workshops. So even though there's a sort of a contraposition with the last talk, it reveals that we're still all sort of sharing the same goal, which is how you encourage change.
Thank you. Renaud.
Okay, maybe what I learned from the kind of panel that is kind of unexpected or that diverges from the work we do is that I think it shows different ways to demonstrate that it's not a solution. There is no solution. In the works of Rotor, I also try to convey that we did not reach anything that looks like a solution to the origin of the motivation to look at those things. But it happened that we feel, and we can see trace in each of the work, that we are looking for position where we can start thinking, or where we can look and connect to the real world with something to start with, because there is the idea of the statu quo is not an option. And so, yeah.
Okay, thank you. One thing that you all have in common, although it was different positions, is that you obviously agree that it's an effort to harvest the material. It's an effort to find tools how to work with it. And my question to all of you, if you're working with non-standardized books or non-standardized trees, or with tiles, or with bricks or other material, or with cables or with metal, and you do this effort, what would have to happen in order to make your life easier and also to find faster and more efficiently a solution for circular economy and circular strategy in architecture, in product design, in urban planning, in building infrastructure, you name it?
Can you be polite and try to get with another question? Because we just said that it's not solution, and the question is, how can it be more easily a solution? No, I just trap you into the question.
Well, if it's not a solution yet, fine for me. How can we find a solution?
I would like to maybe say some.
Anupama.
I would like to say something here, okay, because I think that I would like to say something between both your positions actually, because I think the problem is that what we call solution today is, because I come from the developing country background, operating in dialogue and discussion, which often stemming from the assumption that the mainstream is standardization. And I would like to really interject here that the problem is that that maybe the problem is the over standardization of the industrial age, after industrial revolution. For example, all our clothes are made into S, M and L, and if our body doesn't fit in one of the three, then we feel something is wrong with our body. So obviously it's not wrong with the body. So if it's wrong with it's overly standardized, and compared to the assumption of the over standardized way, one size fits all approach, anything that is unique is appearing to be a problem. But in reality, it's only 100 years of history where humans have made a wrong assumption into the norm. So it is not really a difficulty is what I want to say. My answer to your question is the solution that is doesn't have to be standard. It is case to case, and it's only a mental, it's a problem of assuming in the mind that is a problem. That is not a problem. Humans and the whole profession of architecture existed because we did custom-made housing for people. We did not, the matchbox standard was not normal. It only became like that because of the corporatized culture that has been growing. And we have seen that it doesn't work. So actually everything is fine how it is. And now that we have gone with robotics and all that, to not mass produce but custom made will also become possible with high tech as much as it is possible with low tech. If I do a handmade cake, I can change the ingredients as easily as a robot can do. But the middle thing of having a huge mass conveyor belt doing the same thing was the problem. So let's not,
Thank you.
Go with that assumption.
Thank you, Anupama, very much for this very important comment. I would like to hand over first to Johann and also then to Erich, because the two of you, in a certain way in your jobs, you have to work with standards in order to collect data or to plan with data. So a job without standards, even though those standards are not as old yet, as Anupama just mentioned, wouldn't be possible. Johann.
I don't want to add on the standards. I would like to come back to the major question was what could be a solution to come to a higher rate of circularity. And I think we need to keep in mind what is the reason why we don't have this circularity. And basically, our economy works like that. We take resources, and at the end of the day, we give the resources in the form of waste back somewhere. And to my opinion, in order to keep the materials as long as possible in there, it's quite easy. I mean, you could, on the one hand, make the resources much more expensive, so you could reduce taxes on labor and increase the taxes on materials. Then you would definitely extract less materials and use less materials. And on the other hand, you could make waste management also more expensive, or final disposal of waste more expensive. because the more expensive it gets, then there is a higher incentive to keep the material in the cycle. So basically, I think we need to reflect the kind of resource scarcity what we assume is existing into our prices for materials and into our prices for wastes. And if we do that, I strongly believe then we automatically come to a different design, come to different materials, and so on. Yeah. Okay.
Thank you very much, Eric. May I ask you to reflect on what Anupama said about standardization in building and planning?
I personally think standardization is key to go in a solution direction. I'm pretty sure there is no solution, but we can head in a direction, and even that I think can change a lot of things. And I do think that standardization is key for that, because of course it won't work for everybody, but for most of the people. And that's also a way how to keep things simple and cheap, especially with housing. Everybody talks about that every building is a prototype, which is, in my opinion, not a good thing, because housing should be a mass product. Like, everybody has somewhere to live, usually, I mean. There are simple ways to standardize these things and don't make it bad. Like, you can create good things out of standardized elements, products, whatever. And of course it makes the whole BIM thing easier as well, because you have standardized elements, you have pre-calculated, pre-simulated things that you can just simply use. And to be honest, buildings that are created right now are not, that's not a good way. The buildings, how we were built the last 100, 200 years, it's not efficient, it's very expensive, and it just, the way handling resources is simply not respectful. And I think with technology, we can move a lot, but in order to use technology, we need standardization.
Thank you. Then I would like to hand over to Renaud and to Gwyllim. Both of you invest lots of energy into uniqueness, into finding uniqueness, into doing something with uniqueness. And you just heard that Eric said standardization, I just make it shorter and I have to apologize for that, is a good thing. What do you think of that, and where do you can meet each other?
Actually, I like that you said that the material are not used with respect, and kind of the work we do, and it ends up being uniqueness in kind of experimental work that we do at the periphery of architecture, sometimes within the field of architecture, is try to explore what could be the respectful relation with material. And at the moment we are just there, trying to explore one of the things that is recognized, that was not assumed and taken into account by this optimization and standardization of the previous generation, and all the points that have been mentioned also in the conversation this morning.
Thank you. Gwyllim, may I can hand over to you?
Yeah, I mean, I think certainly we're not interested in standardization at all, and I think it's a very good question. I wanted to discuss it anyway, but I guess the issue that we have with standardization is almost a disciplinary one, in the sense that the trajectory of modularization and standardization and offsite construction is towards the role of the architect being somebody who selects from a kit of parts, rather than the architect as a sort of, a master builder or someone that designs futures that we want to live in, let's say. I think the idea of living in standardized housing also raises the question of standardization for where and for whom? Because the risk, I guess, or the fear, which is just to throw a straw man out there, of course, is that if you have a global kind of set of architectural standards, or a sort of an economic optimization for cheap housing, what you end up with is the same kinds of housing everywhere. And that comes with very high embodied costs and very low resilience to things like changing environments around the world and things like that. And what I think those changing environments are very dramatically changing as fast as we can witness, so having some standardized system of construction for everywhere around the world just seems to be a high risk approach to the needs of different places around the world. But I think the thing that we're interested in is and this is an idealist approach, of course, because we make software, we don't make multi-res housing. And so this is a conceptual interest of ours is in this idea of mass bespoke design and construction rather than mass production of housing. Like, how can you make it just as economically feasible to customize any aspect of a building or its details as it is to standardize every aspect of a building and its details?
Thank you very much. Before we continue, I would like to talk with you also once again about harvesting and how to improve our tools. What questions do you have from the audience to the experts, here or online? Microphone is coming.
I got more a comment. I liked all the talks, because they're all part of a huge puzzle, of the same puzzle to solve. And I especially loved the talk of Mr. Fellner, because it brought us back to reality, because one of the big problems is the problem of scale. As you said, it's we need 90%, and we can just get back 10%. So, and from young Kippers, I also got the one thing is that you need this longevity. So for me, it's always, it's the thing, once you make it long lasting, you do not have to bring it back in a really complex way. And the other thing is with standardization. I'm not just an architect, but also totally into computers. I love standardization. But I also love the beautiful variety of architecture, where every corner is different. And there's always a nice example for me, like New York. You walk through it and it's just a grid, It's just a grid, and just wherever you go, it's just so different. So it's just the question where to put the standards in. Yeah, and I always thought about why don't you do something like buildings that last long, but you can reuse in a good way? Why do you always have to tear everything down, especially here in Vienna? And in New York, you had, for example, these lofts. First they were factories, then there were cool apartments. There was a reusage. So why don't putting brains into building standards that build something that is longevity, has materials that we can use? I mean, what about clay bricks? I'm always still thinking clay bricks maybe too. And using our new techniques like young Kippers, I mean, it's just amazing, reuse this geometry, and the geometry has this power of nature. You have these hyperpolariboids he built, and they're just strong. So when you just put everything together, I think there is a perfect path. And for me, the main question was, and also like Renaud, I loved his work totally, because here you saw the materiality you need. When you take these old tiles and reuse them, it's a total different space. If you just, and I love this Nordbahnhof project. I would really, I have a similar one.
We have so much love here today.
Yeah, no, I think so really, because everybody has the same goal, how to find out to make it intelligent. And I think once you have restrictions, you get a renaissance, because now it's always like you can build whatever you want, use as much energy as you need, as much material as you need, whatever you want, and then you're here like an architect or a designer. Okay, it's mine. It's a plain field. I have no idea what kind of skyscraper, what kind of form, what kind of material, whatever. I can do whatever I want because there are no restrictions. But once you get this restriction, reusing, being able to use it longer, and also for kind of the building process, it's not the building process itself, how you build something. You know, if you do it the Russian way, it just works. Whatever you do, it cannot do that much, but it works. Or the American way, it's just sophisticated and it exactly is doing what you want. And finding here more an interesting, more new approach to kind of reusing it and working with these resources and with all these intelligent things. And also
Thanks a lot.
Yeah, sorry. So my question was more about...
You still have a question, that's good.
No, it was just this, the first thing. What do you think about kind of doing these kind of modular systems that in itself are long-lasting and kind of fulfill all your needs?
Thank you. Let's take this in, because of course we're talking here today about polarizations. The title is optimization or versatility. We're talking about reduction or redundancy. We're talking about standards or uniqueness, and also now we had a perfect polarization. We're talking about Russia or America. So my question to you would be, how can we bring together a certain standardization, what some of you need in order to develop architecture, to develop products, to develop the culture of planning, and still, as you just mentioned, thank you for that, to maintain a certain uniqueness and a certain individualization, like Renaud, you told us, and like also, of course, we can see in the work of Gwyllim and in the work of Anupama. Because when we standardize everything on small, medium, and large, it won't work and we won't love it. So how can we combine those two? Who would like to start? Anupama. First Anupama and then Renaud.
Well, I would like to take also the continuation from the question about standardization first, because coming from the perspective of affordability studies that I've been doing all along in both contexts, if you compare, just because it's a habit to produce housing or coffee through corporatization, in today's world, we think that the standard is the norm and compared to it, things are expensive. But if you actually look at the breakdown of the cost of corporatized coffee or architecture, you will see that when it comes from a large supply chain, Starbucks coffee is more expensive, even in Europe, than the small cafe, And what happens is only that much more of the cost goes into the overheads, the advertising, and the fact that it is a large supply chains management. So it's same we have found for housing. This kind of system of delivery of housing, if it is a standard object delivered regardless of context, it comes with very high overhead costs. It alienates local people, and like every bird and bee was making their own house, now humans cannot even paint their walls without a degree and a helmet. So this is very costly, and all of this is going to change. It is convenient today, but we have to question whether this is efficient. It creates a social segregation. Some can get a high standard housing and some nothing at all. In every city, housing is a problem to afford.
Thank you.
Okay. Then I can follow on your point, Anupama. I had exactly that case in a situation in London. We were working with the students about the places that are going through transformation in London, and one of the train station is getting more trains, so there is money to refurbish the area. And it happened that it's an area that is a hub for the Latin community. It's the same as Elephant and Castle, that was also a hub for a community. But specifically there, the students start to explore what could be done. We were benchmarking a real project, so we know what the developer wanted to do. And basically, to have a coffee shop at the train station with big glass and have a BIM model of the design made it only possible to sell coffee through Starbucks or a chain. But at the place there, reusing the existing element and retrofitting the space, it was still possible to have a Latin community. And so it was exactly the story that you take from affordability studies that I never did, but I just looked at the price of the materials and the big glass through an optimized process, in the end, was not adequate to a Latin community living in London. And I like to observe that.
Thank you. Thank you very much for your inputs. I try a little bit to come back to our main focus of this symposium. And I would like to address the next question to Johann and to Gwyllim. You showed us the one example of the house that was constructed in 2003 and demolished in 2013. And I was highly impressed of how strong it's built. And I was highly shocked of how difficult it is to dismantle that kind of building. Whereas the Gründerzeit house from 1900 looks a little bit like a brickstone box that you just have to dismantle very easily. So first question to you, and then also to Gwyllim, and also I will hand over to Erich because you're having this research work at the moment for Vienna. What can we do, or what do we have to do, maybe in order to find new standards or new regulations in order to make dismantling of architecture, of built environment in future times more easily than obviously it is today? Because this 10-year house sticks together like nothing else.
Yeah, that's a very good question. Probably I would like to change the question. No. I believe that first of all, also what came from the audience, that we should build in a way probably not to easy dismantle it, but to use it as long as possible. I mean, the best solution would be to have constructions, or at least the structural part of the buildings, which we can use almost forever, for a very long time, and then we can, the internal design, we can change it quite easily and adapt it to different purposes for housing, for office, and so on. So this would be my recommendation.
Of course, but I have to, if I may, I would like to interrupt you. We heard it already, but obviously sometimes needs change within 10 years, and then you have to dismantle it. And obviously in this case you were struggling. I mean, not you, but
yeah, the company was struggling, and I guess the company was basically also struggling because we need to be aware now that wrecking companies are used to handle old buildings. So they have technologies to manage buildings which have been constructed 50 years, 60, 100 years ago. And now they face a building which is totally out of the box. Yeah? Maybe I need to add that the building which was torn down was a special building. It was a hospital in Vienna, which was erected, or part of a hospital which was erected 2003. So it's difficult to say whether wrecking companies would find technologies to dismantle the house in a better way, maybe in 10 or 20 years if they have better experience. Yeah? So this is, you know, like if you're used to manage certain types of waste and then suddenly a very different type of waste comes into your way, then of course you get troubles. Of course, we need to learn the lessons out of this and see, okay, which connections are difficult to be separated. Yeah, this is something which we need to implement. But basically, I think that we just can learn how to improve that if we have more experience of dismantling such buildings. Yeah.
Thank you.
Yeah.
Gwyllim, you showed us the mixed reality building with HoloLens and the pebble stones. And this pebble stone sculpture that you yourself, if I understood it correctly, considered not the most beautiful architecture. For me, it's a little bit also a symbol for non-standardized products and non-standardized materials that we can find today in old buildings. So also the question to you, what would have to happen? What regulations do we have to find in order to make dismantling of standardized and non-standardized materials more easily?
I mean, I'll try and answer the question, but I have very limited experience with demolishing buildings. In the limited experience that I have had, and one of the challenges, at least at a relatively small scale, is being able to map existing conditions. So I think some of the talks mentioned that renovating existing building stock is a better use of that building stock than demolishing it and trying to, recycle and resell the building materials in some cases. The challenge with renovating old buildings, at least again, in my very limited experience living in an old building and renovating it myself, is that it's difficult to create accurate as-built conditions of renovated buildings, which makes some kinds of renovation problematic, and it certainly makes reuse of existing materials and structures within some renovations also very problematic. So if there is a better way, a better, faster, cheaper, simpler way of digitizing existing building conditions, which I apologize, I wish I was actually physically there, I'd know everybody's name. But somebody mentioned the challenge of manually modeling from point cloud scans to create BIM models of as-built conditions. Like at the moment, that's a very tedious, time-consuming exercise, but a necessary one. And if that was something which could be readily available to anybody working with existing building stock, I think we'd probably find that more building stock was reused rather than demolished, certainly for small renovations.
Thank you very much. So let's hand over to the point cloud guy, to Erich. That was you. So also, if you want to refer or reflect Gwyllim's answer and also the question to you.
Yeah, you're right. It takes a lot of effort to remodel the buildings because you basically really have to model it. I think it would be really interesting because there are new companies coming. I mean, not that new. I think they are 30 years old, like Lucas Lang, for example. They are highly modular. What is that? A construction company, basically. But they make everything out of wood, and they gave you the guarantee that they buy the building element after you don't want it anymore. So basically, they build your building, and after 30 years, 40 years, if you want something else, they dismantle it and give you money for that. And they use the elements in another way then. So, and also like wood rocks from Hubert Romberg, they have really interesting views on how to use the materials or reuse the materials after after it finished its purpose. In terms of the modeling, if you work in models, it would be really helpful if companies who produce materials would also deliver virtual materials. So they don't just deliver the concrete or the cement, but they also deliver virtual materials that you can use in your models. Because basically, everybody talks about this digital twin, but that's a real digital twin if you have a model that has the same materials with the same properties that the real material, and sensor data and so on and so on. But that would be really beneficial if you get virtual materials from all your companies. That would help a lot.
Thank you. Renaud.
I've been twice challenging you. It feels like you try to reconcile the us and the topics and the subject. And actually, I liked the comment that came that it can be built the Russian way or it can be built the American way. And if I take it easy, probably I like the maternity to be built the American way, and my house or my workshop to be built the Russian way. And can we start to have a conversation about this kind of thing? And I can even be wrong because we've seen a new trend for maternity being at home, so it's less American way, even though I like hospital being designed in true BIM and optimized all the way along with a digital twin so that they can control and optimize what's in a performance hospital. But my workshop, my house does not need to be that.
Thank you. We'll go and have a coffee together after the talk. Any more questions from the audience before we come to the final round? Okay, then my final question to you would be, and Renaud, I would like to start with you, and we'll go in the direction of your talks that you had, of your impulses. Talking about circular strategies is not only circular materials, thank you, but also a certain kind of a circular time loop. So what you do today is working with old buildings and old material. And what you also do today and what you work on and where you invest your energy is an investment into the future. So where people in 40, 50, 60 years will profit from what you do today. That was my intro. My question to you would be, let's assume we meet each other here in the year 2050. So, long time. And you tell us the newest project that you are working on, or the perfect result of a study that you did, something that you found out, and you want to share this great news with us. So Renaud, when it comes to your work of Rotor, what would your great news from year 2050 be?
Yeah, as replied
now
from
I'm
now,
challenging you back
it's maybe that, no, it's just a way to say what is in my mind recently, is that the word circular in 2015 might most certainly have lost its sense, but it could be obvious, and actually it happens to the way we work. Basically, we cut it in two and we deal two things. It's the end of life of buildings, and that's our question, and we know that it's marginal, but there is a way to be respectful and decent and intelligent and feed our cultural development. And then there is projects like needs, and where I would just take the words of Clemens this morning, how to think with multi-layered optimization and not structural optimization, and how to break free from the engineer and the progress doctrine in everything. So circular is dead, end of life is one thing we do decently, and we have all the skills of architects and developer and build expert or build dedicated people for it, and we have projects that are with multi-layer optimization, and it's not something that makes us afraid.
Thank you very much. Gwyllim, let's continue with you. Your greatest project, your greatest news from the year 2050.
Well, as somebody that builds software, 2050 seems very far in the future, but maybe I can try for 2030. I think the greatest news, or the thing that would make us excited, would be in a radically democratized access to craft and to hand making and to customization and to local adaptability, and generally an interest in alternative economic models of producing design and architecture that are sustainable at small scale and within small and local economies. I think that's what we're trying to facilitate through technology.
Thank you very much. Erich, what will the result be, the great news of your BIM circular harvesting model?
Well, I think in 2050 our building activities will shift radically to Mars. So I don't think we will revolutionize that much on Earth. And from building on Mars, I think there will be coming back a lot of technology back to Earth, like it used to be with the moon landing. And I think autonomous construction will be a big part. And if the construction is optimized for robotics, you will need to optimize materials as well. So basically, I think it won't be that big of an issue, at least for the mass housing because I'm not talking about museums or hospitals or something like that, but most of the projects, like the building projects, I think they will be simply put up autonomously, without, yeah.
Thank you. Anupama, what will your news in the year 2050 be?
I think there will be less of a gap between the developed and developing countries, given there will be a common definition of not only sustainability, but access to digital technologies will empower people to such an extent that the centralized long supply chains will be broken down, and decentralized initiatives will have power because everybody can do, they can, and on top of it, we have the COVID experience of noticing that if we stay at home and redefine how work ought to be, and not as a means of livelihood, but as a means to advance our personal potential, then there will be much more of a demand for design. We will be using machines for things like washing machine and all the uncreative things that need to get done, but design will become more important, and the handmade, handcrafted, hand-cooked, all this kind of cuisines, everything, we are going to relish the individuality and local culture. We'll be able to enjoy a better life. And for the architecture practice, I'm looking forward to having collaboration instead of competition as a method of doing architecture, so that we unblock everybody's power.
Thank you very much. And Johann, the guy who brings us back on Earth from the Mars again, what will your newest project be?
I will not talk about the project, but what the finding, what I would like to see 2050 would be that basically we will not talk about the term circular economy anymore, because we have reached it to a certain extent. And the other much more important point to me would be to see that we are in a kind of steady state in our economy, meaning at the moment we are still on a growth, so we still build up a lot of materials in our stock, in our cities. So basically, the problems for the next generation will even increase because they have a higher stock and the higher materials, more waste to be managed. And hopefully until 2050, at least in the developed countries, we reach a kind of steady state, meaning that we are not on a growth, on a material growth anymore, meaning wastes and resource inputs are equal, which allows us better to close circles.
Thanks a lot. Thank you very much for your expertise and for the talk. We're now going to the lunch break until 2 p.m. Central European time. And we'll continue with 2 more sessions. Number 1, theory and practice. Number 2, the concept of productive redundancy. And see you back then again with a keynote speech with a new impulse from Keller Easterling in New York, who's probably at the moment taking a shower and waking up. We are having now lunch. Enjoy your meal. See you in an hour. Thank you.
Thank you.
Morning, good afternoon, good evening, wherever you're sitting. Keller, can you hear us?
Yes.
That's perfect. So let me just introduce you briefly. Welcome back to all of us who joined us now also online and here at the venue at the Angewandte, freshly and newly in your early morning hours. Welcome back to the Circular Strategy Symposium number 2 this year at the University for Applied Arts. Talking today about circular strategies, circular economy, circular planning, and a certain circular knowledge in applying products and planning strategies and tools. And the next input that we will hear is made by Keller Easterling. She's designer, writer, professor, and architecture theorist at the University in Yale. She's also a 2019 United States Artist in Architecture and Design. And she will be talking to us about circular economy and let's say the juxtaposition and the dialogue between circular economy and circular planning strategies. And as far as we know you also from your texts and from your interviews, I'm looking forward to a very critical juxtaposition of different topics. Keller, we are looking forward to your speech. So the next roughly 20 minutes are yours. Thanks for joining us.
Thank you. So I thank you for inviting me. I fear I have so much more to learn from your discussions than you know, material to offer you, especially because I'm kind of reporting from the insane place of the United States. But I'll tell you my adventures in this area. Now, I've often been thinking about kind of indifferent or violent ecologies of building and building subtraction from marketers, financial experts, planners, politicians, all kind of remotely detonating buildings and landscapes, creating destruction, political disenfranchisement, and the ways in which that's almost just trying to bring that process forward, even though it's make it clear that it's just almost a slower form of warfare, that every act of building already a subtraction. Buildings cause the destruction of other buildings, not only because they replace previous structures, but also because they can, just by their toxic presence, cause surrounding buildings to tumble to the ground. We've all seen countless cities, and maybe it's even more pronounced in some places in the United States, where cities that have spent as much time shrinking as they have growing. You can try to replay really quickly since the 60s, the Tower and the Park housing projects, or highways that have cleared land to build and then continue to broadcast a force field of subtraction, or insensitive landscapes like the Amazon, where even the smallest roads can radiate fields of subtraction. The tabula rasa, that's also the weapon of the trigger-happy architect or the urban planner, who masquerades of cleansing and purifying diseased fabric, often disenfranchise entire populations, what Marshall Berman called herbicide. The sustained and overwhelming environmental violence and damage from powers that demolish and poison and abuse and subjugate and try to erase you, not with a gunshot or a drawn sword, but with fossil fuels, with sheltered wealth, with monopolies of data, or murderous policing of the clearing slums, deciding who will live or die. And you know, the other thing that in which you can see this kind of ecology of subtraction is that, you know, most buildings today designed as repeatable spatial formulas with very rapid cycles of obsolescence. This is whether it's a recently constructed casino or a house or a massive sports stadium. Financial industries surround this seemingly static and durable building with a volatile balloon of deflating and inflating value. This is kind of the, I guess, the commercial and bureaucratic shock and awe. And ruin and decay has its own pornography. Disassembly and tear down are popular art forms. The newest approaches to building removal even appear to retract skyscrapers into the ground. So in a way, trying to kind of make with half closed eyes an ability to detect a kind of accelerated time lapse in which large swaths of building and landscape seem to be simultaneously cultivated and harvested, or built and unbuilt, trying to see an economy where subtraction is the other half of building. part of a larger work, which is just trying to think about these design ecologies and alternative ways of registering our design imagination. Form making in another key, where the object of design is making an ecology, is making interplay. So not only objects, but relationships between objects, the design of interdependencies and chemistries and chain reactions, designing not only a single object, but a platform for inflecting populations of objects or setting up relative potentials within them, designing forms, protocols of interplay that have a long temporal dimension so you can adjust to changing conditions or moments when you're politically outmaneuvered. So I hope that this kind of idea of designing ecology might be of interest to you. I know that this, what you're talking about here today is much closer to, probably material science, but these are the kind of things that I've been puzzling over, and also thinking about sort of designing as entangling, but also looking at so many abusive organizations that create automatic harm from financial variables that are filled with multipliers and switches that have population effects. So thinking even as an architect, it doesn't make sense. I'll go back. It doesn't make sense for me to try to kind of rush up and fix one of those houses. What makes more sense is somehow to try to design a form that can piggyback on that environment and use it as a multiplier or something else for a population as effect. Is it possible that the very multiplier that fueled an abusive market might amplify its antidote, or in a kind of reverse engineering? How do you use some of these environments, not to collude with them, but to sort of short circuit or unwind abusive markets that are failed or distended? And trying also with the written word to go beyond the kind of anointed digital legal econometric languages to talk about spatial variables that could counter some of the thin abstractions of finance with tangible, heavy, lumpy values that have to do with position and proximity, solids, climate, mutualism, matchmaking in communities. So how can you decommodify by overwhelming capital with some rival modes of exchange that have other powers besides those of financial abstractions? How do you retreat from exhausted floodplains and wildfires? And how do you stop encroaching on sensitive landscapes? So kind of in short, how is it possible, if architects know something about putting the building machine into forward, do we know anything about how to put the building machine into reverse in a way that might address a community scale as well as the planetary scale? So I've long been writing about these forms of subtraction since I taught a seminar about it in 1995. And that started with sort of charting the demolition industry and the waste industry. But more recently, again, asking if there are ways to reverse engineer development by operating on many different financial or environmental multipliers, from mortgages to cars. So I can offer a few examples here. I was initially fascinated, and I'm sure you're talking about this today, with the Kreislaufwirtschaft, or the life cycle infrastructure of material streams from the German automobile industry, the bar-coded components were researched. An organization of which there are now, many are in the world, like RAP, Waste and Resources Action Program, a nonprofit that works with construction and demolition industry. I mean, this is all so familiar to you, or a company like Kajima that was disassembling buildings in ways that allowed them to recycle a huge percentage of the materials. These are just some anecdotes, but shift focus back to the US, which presents for someone like me the biggest puzzle, because there are large waste management firms here that have really powerful lobbies that edge out smaller players. So they make it nearly impossible to think about looking to the EPA and regulation or some kind of centralized directive, and even waiting for the EPA to establish some kind of life cycle calculator for the value of discarded materials is too slow, because everything is commercially driven. Even the recycling organizations that I was just showing you there are commercially driven because they are organized by with the private support of these 4 or 5 waste monopolies. So there's few efforts that achieve any scale. Maybe, you could look at something like concrete, which has enough tonnage to achieve some scale. But the machine you were just looking at is a sort of eco crusher that leaves concrete debris by the sides of roads, so it can be used as a aggregate in the next building of roads. I mean, that's America, and that's the US. I mean, and that's even the kind of tenor of the way those companies operate. The politics are very red in a way. So I've also been thinking about, well, how do you outwit the market with some unexpected economies? This was a project called Stream that I worked on in 2009, and gave up eventually. But it was a proposal for a GPS-enabled internet smartphone marketplace for materials of building teardown. Like we've all seen a number of these. It's some kind of cross between eBay and a gift economy internet forum. So it was trying to find a way to demonstrate how you could post items for free pickup that would determine value in a kind of real-time bidding. But the whole purpose was to allow smaller companies, not just these large monopolies, but smaller companies to harvest larger volumes of material from small lots. From the other side, those who were disposing would be able to avoid the tipping fees of these larger waste contractors. And during the financial crisis of 2008, you did see, and since then you have seen many things that are traded in similar sorts of markets, all kinds of portable fixtures, equipment, interior finishes, remainder tools, materials. I even saw it, at once, the eco crusher itself being sold on eBay. But again, nothing of any scale. When I wrote a book in 2014 called Subtraction, only one part of which was about what you're concerned with today, this sort of circular economies, I could only report kind of anecdotal evidence. There was an organization called Restore that's now called Eco Building Bargains. And the way it operated was to try to, again, everything commercial, it could only try to mimic big box stores like Home Depot, except that the contents of the store were donated construction materials that would otherwise have been waste. I could report very small scale efforts like urban lumberjacks in Cincinnati who were harvesting materials from shrinking cities that were doubly hit by the financial crisis. They were already shrinking and then doubly hit by the financial crisis of 2008. Or another kind of similarly rugged sounding deconstruction company called Bearded Brothers, who were harvesting material from cities in Florida, and were even trying to kind of play the carbon credit game with their recovered wood. But even these groups have kind of faded into the background. It remains anecdotal. There's now more than there was then, a handful of gypsum recycling companies, but the materials are likely to end up in agricultural uses rather than in new gypsum board. Yeah, there's more material trading on major platforms like eBay, social media, more than a few years ago, but not achieving any scale. and again, these powerful lobbies, material lobbies, like you're looking at an ad, or not an ad, but a bit from the plastics lobby, plastic makers in the United States. And you can see here that the lobby is really slyly seeming to advocate for circularity, even as they're trying to kill any regulation. So if you go further into their site, and they try to get you to sign up to ditch the plastics tax, which is being discussed now. This is kind of the sneaky, lying world of US politics rather than a kind of reasonable government-led strategy that many of you are helping with and working on. In the US architecture world, where I can say a few things, there are some of those who operate like Rotor, who I'm sure has come up today, a Brussels-based architecture firm that mines and warehouses and redesigns from a cache of used building materials. I don't really think any architecture firm in the US quite has the profile that Rotor does, though. Or among architects, you might also look for design for disassembly project. This is a guide for that was prepared by Brad Guy and Nicholas Cheramboli for the city of Seattle, and some other sponsors. And it's kind of fascinating in that it goes beyond architecture's kind of pure dreams of prefabrication to simply imagine the construction factors that would be affecting disassembly and try to retool them. So again, these are, you're trying to theorize on the kind of back end of construction. And or you might look at Leda Aguirre, who also in the US at Taubman University of Michigan is exploring also a rich overlap of cultural and logistical factors related to the avalanche of commodities that are produced, thinking not just about recycling, but disassembly and flexible, reusable assembly. They're even holding a conference this week called Post Commodities that might interest you if you can handle a time zone shift. But I just want to go back to that commodity because, this house, which is the center, the filter of so many of these materials, it's important, I think, to see it as a field where the factory is in the site. Because of the FHA long-term low-interest mortgage that was introduced in 1934 during the Depression, it was seen as the house was seen as a vehicle for jumpstarting the construction economies and the banking economies and for employing numbers of people. And so it is a cross between an assembly line and an agricultural field where, you made 17,000 slabs, framed 17,000 houses, shoved in 17,000 TV sets. And this is not really a place for building houses, but a place for making a kind of currency to refire the economy. And it has since always been connected in the US to money. Everyone looks at that house and wants it to behave like money. And you see during the 2008 financial crisis, you might look on the news and you would see, you know, a report of how the house how there were so many houses that were defaulting, and isn't this a tragedy? And then a few seconds later, you would see a report on economic housing starts as a positive report about employment. So employment has always been attached to this form. And even it's the reason, as I'm sure you know, the reason why a lot of the prefab ideas did not work in the United States, because the construction industry was tooled only for stick construction. So in the US, while we're waiting for some sensible legislation endlessly, is there some way to get at some of this material by sneakier means? And I've been trying to think of, have I already gone to my 20 minutes?
I'm running to my microphone. I'm afraid, yes.
Okay. Well, I'll just quickly say that I've been trying to find ways to work on this by operating on the mortgage formulas for these, even thinking about, you know, how you might regroup and introduce small forms of collectivity in mortgages that allow them to regroup and actually create a kind of subtraction of that can retreat from wildfires or from flooded areas. But I'll stop there. I mean, trying to also see how the building subtraction might be seen as a means of employment. So I'll stop. Thank you.
Keller, thank you very much. Thanks for your input. You haven't chosen the best, most optimistic place to live with your point of view. I can assume that you have kind of a pain in the US.
Yes, I mean it's difficult to talk about some of these problems because one is trying to kind of outwit a market without colluding with it.
I have 2 or 3 more questions to you, but I would make it after Daniel's keynote. Daniel, are you here with us?
I am. Can you hear me?
Yes, we can hear you. So let me just introduce you briefly. Daniel Veenboer, I hope I pronounced your name correctly. He's head of sustainability at EFFEKT, an architecture, urban design and research collaborative based in Copenhagen. And he's also project director for the installation Ego to Eco. Today he will be presenting us some projects that deal with different qualities of circular strategies, which are, for example, preservation, reuse, upcycling, and regeneration. So after Keller's theoretical input, now we come to the practice. Daniel, the next 20 minutes are yours.
Great. I will try and stick to them then. Today, I'm going to talk about EFFEKT's approach to circular strategies within the built environment. And yes, this is us. This is EFFEKT at one of our projects called Camp Adventure Tower. We are a Copenhagen-based office currently employing around 50 talented architects, designers, and urban planners. And EFFEKT is Danish for impact, as the name suggests. Our focus lies in understanding the impacts that our buildings and cities have on their surroundings. And we combine systems thinking with a human-centered approach to design so that we can accelerate the green transition in the built environment. And we do this to create healthier living places and environments for people and planet. We have different departments. So we work with architecture, urban planning, landscape and urban design, and research and design, a new unit which has emerged over the past 5 years at our firm to help our clients and collaborators explore new business opportunities and strategies that go beyond the traditional realm of design consultancy. And as we see it, by working with these multiple aspects of design in this holistic way, we're able to better explore the ripple effect that buildings have on their surroundings. So looking beyond the walls and sites of these buildings and urban spaces to understand how they influence the communities around them, the economies that support them, and the ecosystems that sustain them. So through a deeper understanding of the parameters that influence these complex systems, we aim to do more good rather than less bad, designing buildings and urban spaces that have a lasting positive impact on their surroundings. So today I'm going to show you a series of projects that hopefully exemplify this approach to sustainable urban development and presented through the lens of 4 circular design strategies. So we're going to be looking at preservation, reuse, upcycling, and regeneration. So the first project, Rosenhöj, is looking at the first strategy of preservation. How can we extend the lifetime of buildings while enhancing quality of life for their users? And it's estimated that about 90% of today's buildings will be in use by 2050. So for that reason, preservation and renovation is definitely an important strategy in improving the quality of life for people while reducing the carbon footprint of our future urban development. Rosenhöj is one of EFFEKT's earlier transformation projects, and the project is based in Aarhus in Denmark. The main vision for this transformation was to open up the degrading housing area towards its surroundings in order to create a new sense of identity and community inside this social housing complex. And here you see the effect of the transformation, which we achieved by working with 3 types of intervention related to specifically infrastructure, landscape, and architecture. So from an infrastructure point of view, we worked with linking dead-end streets and extending this existing road network to connect the community with its surroundings. We then transformed a landscape which was pretty bare, characterized by paved areas and lawns, which require a lot of energy and cost to maintain. And we transformed these into a series of interconnected parks that were shaped by the local communities around them. And then finally, from an architectural perspective, we introduced new housing typologies and adapted some of the old ones to create more variation in the building mass and a better visual connection to the surroundings. So here you see an image of what the landscape looked like before. Pretty boring, monotonous landscape with lawns and large paved areas that are not really usable by the residents. And then the transformation afterwards, aiming to create these vibrant community gardens that the residents could personalize and make their own. So the buildings before, we worked with energy renovations that were performed on the facades and different designs and materials that were used to create more variety and a sense of ownership. So as you can see here, working with tiles on one of the buildings, and then giving each building its own unique identity. Another really interesting thing we did was to actually take the generic address that each building block had. So for example, you would be living before in block 5, floor 3, row 2 or something like that. And then giving each building its own name with its own address, which actually added to an increased sense of pride and ownership of the residents. So the result of Rosenhöj's transformation was 3 times fewer emissions than if the whole housing complex was torn down and built from scratch. The energy required for heating was halved through solar energy production. vacating dropped from 26% to 9%, and the waiting list for this area increased by 14 times. So the second strategy we'll be looking at is reuse. Can building systems work like ecosystems? And here I'll present the Urban Village project. Since the concept of waste doesn't really exist in natural ecosystems, our vision for this future building system was to design out waste. And we did this in partnership with Space 10, IKEA's innovation lab in Copenhagen, for IKEA. So we looked at three main challenges: sustainability paradox. So as urban population grows and housing stock doubles, we need to actually reach net zero emissions by 2050 to avoid dramatic climate change. The affordability paradox. So the amount of households will double by 2050 with 3 billion people in need of a new home, but only 7% having access to formal housing financing. And even though we're more people living closer and connected than ever, depression is now the world's most widespread illness. So rather than tackling these 3 points as silos, which we typically see in most housing projects, we made sustainability an integral part of the business model in order to unlock new forms of community based on the sharing of resources. So here, sustainability, affordability, and livability were woven into the concept from the very beginning. And we asked ourselves if we could customize and scale homes the same way IKEA does with furniture, making use of efficient construction methods like prefabrication, which could speed up delivery times by up to 50%, resulting in savings of up to 30%. And we envisioned this as a modular building system built in wood, which could enable greater flexibility of both the building envelope and interior floor plan so that homeowners could choose the housing type that best fit their needs, both financially and functionally. So this home was designed for disassembly with material cycles in mind and the idea of being able to trace the life cycle of each building component through the use of material passports. And in order to achieve this, the building components were divided into shearing layers based on their function and expected lifespan. So as we see it, a modular and adaptable approach to the housing market makes for much more personalized and interesting spaces to live in. And rather than a one-size-fits-all approach to housing, we envisioned a building system that could be tailored to the needs of a wide range of users and lifestyles. And working with the idea of affordability by design to promote access over ownership and draw upon the resource efficiencies of co-living so that you can save on individually owned square meters and instead dedicate space on the ground floor to shared amenities like communal dining spaces, laundry, and daycare, for example. Yeah, and we see this as a new way of building and living that can ensure high quality homes that are better suited to the needs of the people that inhabit them, offering communal facilities on the street level that support the needs of everyday life while enabling people to be part of a more vibrant community and enjoy a social lifestyle where they live. And with high quality public spaces that invite the outside in and offer useful amenities that would connect each urban village with its surroundings. So this modular building system, we envisioned it being reconfigured and scaled to fit a wide variety of contexts and building typologies, from urban infills to new urban communities, such as this one visualized here. And then our third strategy, upcycle, how can we give new life and value to old prefabricated building components? Here I'll talk about resource blocks. So 374 million tons of construction and demolition waste are generated in the EU every year, making it the largest waste stream in terms of mass. And resource blocks is our proposal to try and tackle that problem. The project is based in Bosmose, and we were invited to develop a strategy to find new ways of repurposing the degraded building stock of this large social housing area in Denmark. And to give you a bit of context, Vollsmose is one of 15 housing areas on Denmark's so-called ghetto list, which is an unofficial classification, or an official rather, classification of underprivileged residential areas with high rates of unemployment, crime, and social fragmentation. And according to the government's new plan to diversify these areas, the building stock of Vollsmose should be demolished by 35% to make room for new smaller scale typologies. And it was our job to find new ways of using the old prefabricated concrete building elements. So we started by looking at the building components which could enable the greatest savings in their second and third life cycles. So here you can see floor slabs and core walls. They have the greatest potential for saving in those second and third use cycles. And then we worked with smaller subdivisions of these elements to ensure future disassembly and reuse, combining them with a timber grid structure that could accommodate these concrete floor slabs, walls, and stairs. So this hybrid strategy of combining a timber framework with prefabricated concrete elements enables greater savings in terms of materials, energy, and costs compared to simply crushing and recycling this concrete. And here we visualize the process of taking apart the old buildings, storing the components on site in a material bank, and then reusing them in the new construction. This hybrid timber system benefits from the negative carbon footprint of wood. And as we see it, it can be adapted to create a wide range of different housing typologies. So here you can see a buildup of some of these components in a point house typology, where the original load-bearing walls are used to create the core in this new building, and openings in these walls allow for a more flexible floor plan to accommodate a diversity of apartment types. And here an impression of the interior of one of these apartments. So merging the biophilic properties of wood with the heritage of the old prefabricated concrete elements in this strategy. And that brings us to the final strategy and project, which is our proposal for this year's Biennale of Architecture. And here we look at how we can create an exhibition with a lasting positive impact. We were invited to participate in this year's Biennale of Architecture in Venice, and the starting point was really to ask ourselves how we can design an exhibition that can leave a lasting positive impact and respond to this question, which is the overarching question of the Biennale: how will we live together? So our installation is called Ego to Eco, and it showcases a series of architectural prototypes that envision new resource-efficient ways of living and building in greater synergy with the natural systems we're a part of and rely on. And the 1,200 seedlings you see in the installation, they were pre-grown from seed at a forestry nursery that we collaborated with. And they come together to create a miniature forest that becomes the centerpiece of the installation and a living representation of a natural ecosystem. So we see three phases in the installation: propagation, where we source the seedlings; incubation, where they're grown throughout the course of the exhibition in a hydroponic greenhouse irrigation system that we actually control remotely from our office here in Copenhagen. And then after the life of the exhibition, as we'll see, they are planted out and become a forest. And we designed the system for disassembly so that when the exhibition was over, we could actually take everything back with us and set it up again in a new location, rather than just leaving everything behind, like unfortunately many exhibitions do. And yeah, as you can see, something quite magical happens when you use real trees in an architectural model. And yeah, definitely people notice that. The fun thing about this little experiment is that it reminded us that natural systems, of course, have a life of their own. So this is what the exhibition looked like at its opening. And this is just a week ago. So we learned to embrace that fact and This is what it looks like, 5 months of growth of a miniature forest. So in 1 month's time, at the end of the exhibition, these trees will be harvested, they'll be planted out, and then they'll be managed responsibly. The trees will become the first new inhabitants of a new project of ours, a housing project in Denmark that combines real estate development with afforestation to regenerate the landscape. And these small trees will eventually grow up, absorbing more than 1,000 tons of CO2 over the next 50 years or so, and providing a recreational forest landscape for the new inhabitants of this suburban settlement. So we see research and design projects like these as part of a larger transition from ego to eco, as the exhibition is entitled, from this human-centric perspective that exploits nature to an ecological development in greater sync with the natural systems we rely on. And in this perspective, we see our living environments and ourselves as part of nature rather than apart from nature. So implementing this way of thinking and this synergy in our work becomes quite central and vital. And that's actually the last slide in the presentation. So I'd just like to wrap up by summarizing some of the strategies we looked at in the projects, with Rosenheu extending the lifetime of existing buildings and products, with urban villages designing with the entire life cycle of the building in mind, resource blocks, keeping materials at their highest value, and then the Biennale and the Naturbühnen preserving and regenerating ecosystems. So hopefully you'll be able to take some inspiration from these projects and maybe apply these strategies to some of your own work. Because yeah, we all need to do our part in basically creating the change we want to see in the world. So thank you very much for listening.
Daniel, thanks a lot also for your input. Daniel and Keller, I would like to ask a few questions to the both of you. Keller, can you hear us?
Yeah.
Okay. My first question would be to you, Keller. So what Daniel just presented, his projects, his solutions, his ideas, especially for preservation and reuse, would it be a solution for you? Would it be a solution for settlement structures in the US for the future?
Well, it's wonderful, really wonderful work, and work that I really admire. I don't know the answer to your question, but I think it is the question. You know, it is how, and I'm sure that Daniel is struggling, and his colleagues also struggling with this. You know, how do some of these ideas that are, you know, make so much sense, how do we, what's the delivery mechanism for them, you know, in culture? How does that work? And, you know, it's so much easier to imagine in reasonable places where you all are living. I am, you know, in the stupidity of the United States, but it is crucial to somehow think about, you know, what are the political obstacles? What has a chance of gaining scale? But, you know, in my work too, I wouldn't use the word solution, because one isn't looking just for a solution. You're looking for like anything, anywhere, at any moment, you know, just any strategy, any trick, you know. So anyway, that's just some thoughts. But I congratulate you on this work.
Daniel, how could you, with either Keller Easterling in person or with her position in general, work together? And how could the two, let's say, strengths of you could benefit from each other?
Yeah, I think it was so interesting seeing these different kind of forms of subtraction, charting out the demolition landscape, it's really crucial to understanding kind of the urban metabolism of these really complex cities and urban spaces that we're designing for, and is actually something that we seek to do much more of in our everyday work, is working much more interdisciplinarily with experts from different fields and drawing in knowledge that we ourselves don't have in-house, because as Keller mentions, we really need to do everything we can to kind of scale these solutions and draw upon each other's strengths and experience and in-depth knowledge. So yeah, I think that would be definitely one way. And of course, having open, constructive dialogues like the one we're having today is just vital to kind of pushing the agenda forward. So thank you also for the opportunity to speak and present here.
Thank you very much. Is there a question here, an icebreaker in the audience to either Keller or to Daniel? There's one question in the first row.
Yeah, it's not really a question, but I would like to ask Keller to continue a little with her talk, because when I understood it correctly, she has a kind of strategy or perspective to offer from her point of view, how to manage that situation or how to contribute to mitigating the situation in the US.
Well, I was going to show you a couple of projects. One that was trying to get under the hood of those massive organizations by tinkering with the mortgage that was the source of the sprawl, and attaching, and then I was also going to show you another one, which was looking at reorganizing the car. So at transportation, thinking about how if the car is reorganized, what does that do to the landscape? So in both cases, looking at a kind of counter germ within a kind of contagious landscape, or looking at for a kind of counter contagion. So the mortgage one was attaching was rating mortgages not according to financial abstractions as they were done in mid-century in the United States, or as they were done in 2008, 2007-8 financial crisis, but rather rating them according to their more tangible climate risks, and then allowing mortgages some degree of collectivity or grouping. This is a little bit like the ways that kidney donor pools have been recently pooled to create a greater access to kidneys. So it's just like allowing for some degrees of collectivity in a different way of rating, and to see if that would actually allow a failed market to literally kind of subtract. And the car one had to do with another kind of switching. I would take two. I don't want to take a lot of time to describe.
Thank you very much. I have one additional question to Daniel also. Focusing on the Space 10 project that you did, because today we're talking about the question optimizing or versatility. So reduce to one single optimum, or to be redundant and to allow different possible solutions. And the Space 10 project for me a little bit is a reunion of both strategies, because on the one hand you have a very standardized system, but then you also have unique solutions for individual wishes by the people. So what would be the next important steps to maybe try out and to build one best practice example like this one?
I think the next step is really to work directly with IKEA, which is what we're doing now, to be able to prototype kind of the minimum viable village in order to test out this building system and really understand if IKEA as a company that owns the entire value chain can enable these take-back schemes that somehow monetize the building components in order to keep them at their highest potential value. So I think we would actually, the first step in this would be to really nail the building system and really understand how we can design for disassembly in collaboration with a company like IKEA that owns the supply chain, and then looking at the strategies of how to incorporate access over ownership and new financial models, which is probably far too complex to tackle all at the same time in a radically new building project. But that would be our approach, and is what we are working on right now, actually. So hopefully next time we present, we can show the outcome of that.
Thank you very much. And one last question to Keller from my side. Keller, thank you for giving us an image of a country where preservation, reuse, upcycling, renovation has not achieved its, let's say, its peak yet. So you still have some potentials. My question to you is, if I look what I see on television, international television, and I see some shows like I'm thinking of one in Texas, Waco, a fixer-upper, and you have shows in California and also in Indiana where people in front of the camera renovate and preserve and upcycle houses. So that's like a new trend that we've been observing for the last 5 or 10 years. Do you think that bringing this topic to a wider mass, like for example with TV, is one of a possible solution how to make this topic more, how do you say in English, bewusst, more aware, thank you, more aware to many people. So does this trend, does this movement give you a little bit of hope?
I think it's in the way you're thinking is the way that, you know, maybe one somehow does have to think in the United States of thinking of something that would make it mediagenic some way. I mean, I'm not sure that these kind of TV shows are actually encouraging the kind of really deep reuse and circular economy that you might hope for. But yeah, they are in some ways saying at least that it's not just new housing starts, new construction that is valued. So there is something there. I don't know how to measure its effectiveness, but it's also so clear to me as we talk that, you know, as we're thinking about planetary solidarity and planetary alliances, it's so crucial that we you know, work on the biggest abusers like the United States with anything we've got, you know, from anywhere, you know, not just sort of maintaining our, you know, national context.
Okay, thank you very much. Thanks for your expertise. Thank you. We have one more question, but I have to ask you to be very, very short because we are running out of time. So, short question. He can't be short. Okay, so then we say thank you. You know how to connect with each other. There is possibilities today. Thank you, Daniel, and thank you, Keller, for your inputs. We'll do a short 10-minute break, and we'll continue with Manja and Wolf in the last panel. So Manja and Wolf, go and have a coffee, and see you in 10 minutes. Thank you.
Thank you.
Hi, Manja. Welcome back.
Hello.
Hi. I've been seeing you all day in front of the camera, always again and again. So thank you for joining.
That's good. Thank you.
Manja, you will giving us the last talk today for this for the day, and then Wolf Mangelsdorf will go into a respondence with you. So we had one keynote today in the early morning, and you will now give us a little bit of a juxtaposition keynote to the morning one. And let me just introduce.
No pressure, right? Yeah, yeah.
No, not
absolutely
none.
No, not so.
Let me just introduce Manja briefly to you. Manja van der Worp. She's director of the YIP Structural Engineering in London, an engineering consultancy bearing extensive knowledge of advanced structural analysis and fabrication technologies. And whereas in the morning you heard a speech on the power of optimization, you will now hear, no pressure at all, Manja, to you, a speech on the power of redundancy. Thanks for joining, and we're looking forward.
Thank you.
We see everything, yeah? That's fine.
Yeah, great. I also realize I use a massive font, so sit back and relax, and that's it. Yeah, so I'm going to introduce to you Rubens structures in defense of redundancy for lifelong lightness. Yeah, super happy to be here. And yeah, it has been great to hear all of the kind of discussion around circular strategies, and hopefully I can shed a different light to this. This is me, that is almost, let's say, 1.5 years ago, where we were lucky during this summer to go for a 2-month cycle ride from UK to Spain, which has been really amazing. Love being outdoors. And aside from that, I'm also a structural engineer and an architect, and I am known for challenging optimization. As I say here, yeah, you can ask all my students. So aside from being a structural engineer, I also teach, and yeah, I'm quite happy that yeah, I can propose to you a different view, because optimization obviously has many kind of possibilities and opportunities. But what I want to challenge is just merely kind of reducing mass, or you know, picking the best solution from a series of options. How can we kind of challenge this and make this in relation, or think about lifelong design through redundancy? So these Rubens structures, as you see here, part of a beautiful painting, have a bit more flesh on the bone. So this is what I call redundancy. But I'm going to explain to you that they're still light in the way that they use their materials and with efficiency, because they have the potential to extend life, and we could build in multiple configurations at the start of the design. So YIP is my structural engineering consultancy in London, and it stands for Yes, It's Possible. So I love to do fun and funky things. Structural design, geometry, and fabrication is the kind of main core of this. So I would like to first show you some projects that talk about this extended life kind of potential. So this is merely kind of looking at multiple locations, as opposed to what I will address later, multiple configurations. So I've just been involved in developing this inflatable structure, which is held down not on a foundation, but actually just by filling the base with water. So leave no trace, minimum impact for the COP26 in Ireland this year. And obviously it can be deflated and be reused. With the same designers, Ecologic Studio, I also developed this playground, which is currently in Warsaw, but will move along to different places and is completely designed for disassembly. This is not necessarily Rubens, but it means that this is a single state kind of design, which can be disassembled and reassembled into multiple locations. Obviously, because of this, we need to kind of address connections, etc. And here you see a view of the structure. So I've also been involved in developing more like systems or products, structural products, as of one you see here. This is Minka. So this is a housing system that we are developing with HAG architects in Copenhagen and with Tolweg Engineering in the US, because it's for the US market. And here we see that it is also based on a system that where we could pick, for example, different lengths of elements or change change the kind of inclination to kind of not have just a kind of straight portal frame design, but actually redevelop the geometry. I'm also working with kind of innovative materials and, for example, thinking about circular strategies using recycled plastic. This has an NDA, so I can only show you a very kind of nice in-house test of a 3D printed recycled plastic beam, which will be for a pavilion that will be first in Gstaad and then move to a glacier. And again, like really thinking about design for disassembly and reassembly in the same state, but also thinking using recycled materials. So if we are thinking about design for disassembly and reuse, we might start to think about separating elements. And in this workshop at IAC, which I did last year, we developed just a simple kind of structure, actually, where we have concrete elements that are purely in compression, held together by cables, which are purely in tension. So if I want to disassemble, obviously, this is a very easy and simple way because each element has one role. So I could, for example, redevelop it into the structure that you see on the left, where again, because of post-tensioning of the cables, we can put compression, pre-compression into the concrete elements. And I have a system that cannot be only moved and let's say disassembled and moved and reassembled in the same state, but it has the ability to be reassembled in a different configuration. So these are some of my favorite lightweight structures from Robert Le Ricolet. And obviously here we see also already the difference between, or separating compression and tension elements. And I'm fascinated by the idea of having a set of components that then can be disassembled and reassembled. And that is what we then call Rubens. So this flexible reconfiguration, and this is the last project of this introduction, doesn't necessarily just have to be like simple stick elements, like a concrete compression element, or a cable that is always in tension. It can also be like more like this kind of volumetric or block-like systems. And here they're also held together by cables, but the elements are not only purely in compression, they can also take bending. So we can take inspiration, let's say, from this kind of more like truss-like systems and move on to elements that can take different roles, and how we combine them allows for a reconfiguration into a different state. So here we see two images. So we started this project with architects, fabricators, and structural engineers, professionals in London, together with students. And then this project has moved to Denmark, where it has been reconstructed for another symposium in a different configuration. So the components are the same, but they have been reconfigured and can generate a different space. So if we discuss this idea of Rubens, where we have this beautiful, more voluptuous structures that are not just super skinny for one state, it allows for efficiency kind of through this redundancy, because it has the possibility to not only be disassembled, but also reassembled for a multi-state design. So in redundant structures, not all elements work to their fullest capacity on their own or equally hard, but they do as a cluster. Elements can take multiple roles in a structure, and parts can be mobilized differently over time by directing loads in a specific way. And they are not adding more material, but we mobilize the less used kind of load pass. So this is a completely different way of thinking. So instead of having one element that has one specific role, it is a cluster that is going to provide a certain performance. And we can then change by adding another element, let's say the performance of that cluster, in order to either create a more bigger space or add potentially another story, for example, on top. But I'm going to explain this in a bit more depth. So for this, we need to design adjustable components which can cater for an evolving building through amending capacity and performance. We want the ability to dis and reassemble, and we want to make load pass flexible. So the first point, which structural elements do we need to design flexibility for lifelong design? So we need, like when we look at existing kind of structures that are already designed for dis and reassembly, for example, this is Rotor, so one of the biggest UK concrete fabricators. They've also developed their own prefab concrete column and beam system. So we could disassemble it and reassemble it, potentially reassemble it in a slightly different configuration, but still beams are designed as beams and columns are designed as columns. So what I'm thinking about is that what if we have elements that have no name? So it's not that one element that is a column or one element that is a beam, but a cluster that generates either a compression strength that we need or a bending strength that we need. So if we, again, try to simplify that, we could say that on the left-hand side, when we are looking at chess, each pion has its own role and its own capacity. But if you look on the right, which is what we call difference in degree, these elements are not just different in kind because they do one thing. They just differ by the clusters that they are within, and because of that, create a certain or have a certain capacity. So again, in terms of chairs, on the left, we see a Rietveld inspired chair, and we see that we have, you know, the kind of very simple kind of seat and columns and backrest, where on the right, we see a chair that is much more based on a smaller amount of component or larger amount of components, but that are not either the backrest or, you know, one of the seat elements. They are actually intertwined and combined together, create the performance required for us to sit on this chair. So here again, a little diagram of this. So this means that if we compare on the left a very simple way of columns and beams to something that looks a bit more alien somehow, because the elements maybe don't have a name, but they are still performing as beams and columns as clusters, we can actually work with these discrete elements that have initially no name, but have the ability to be dis and reassembled. So the cluster is the capacity and provides the structural behavior. And on the left-hand side, you see our proposal, winning proposal for the 2017 Tallinn Art Biennale project, where we proposed actually 3 structures, all with the same components, but that could be reconfigured. So a beam doesn't look like the beam at the top, but the beam actually looks like a combination of pieces, as you see on the right-hand side. So these elements don't have to be just this linear kind of or kinked elements. Another project that I worked on is Mohoken, which is a recycled plastic, again, structural component-based system for the housing market. And that is based on these hexagonal blocks. But here we also experimented with, can we remove elements from the clusters for free? So because if you want to make an opening, so sometimes it's not only about extending, but also to make simple openings, can we do this within the structural framework of what this specific component or cluster of components has to offer? So Mohoken started actually with the Black Betty, and this is the element that you see here. You see on the left-hand side, I don't know if you can see my mouse, but here, this was the location where we were supposed to have the structural element that would be put inside. So actually, the block itself was merely an infill kind of panel and not performing structurally. What we wanted to do is actually make a structural panel out of this. So here you see that actually instead of separating the structure from the panel, it is combined, and yeah, you see some testing here done. It's important because obviously it's a new system, it's a new material, and we're trying to find out what actually are the rules. And obviously we need to start kind of simple and getting a feel for what are issues of working with the recycled plastic material, but also with the system itself. So then what we developed was a really strong, so a not super lightweight structure, because we embedded the capacity within the cluster, let's say what we see here on the top, of hexagonal elements that work as a kind of beam or almost as an arch spanning over this opening would allow us to remove elements. So we said, okay, great. So actually people could buy a number of these components, but during the lifetime of their building, they would be able to simply remove elements from within because the structure has been designed for that. So just to go back to that question, so what kind of elements that we need to design this lifelong flexibility or multi-state design? The first rule would be to design elements that have no name, but get a behavior because of clustering, which is the second point. And we could actually think about this kind of smart clusters, which allows us to, for example, create openings as which I showed with Mohoken. So in Rubens structures, there's always active and more lazy blocks in every design, where some of them are working really hard and some of them are not doing much at one state, but they might be reactivated at a later state. So that is coming to the second point. So how can we design this ability for dis and reassembly differently? How do we do that? Another project I worked on is mass bespoke. We already discussed a bit about, the idea of having a system kind of design. So this is another kind of block-based, volumetric timber block-based system, but they call themselves mass bespoke because they want to alter or allow for the designs to slightly different. So it's again a design of a structural product as a system. So they have like all of their kind of softwares that relate to fabrication and to engineering in place to create this flexible digital framework. So we had been asked to also really come up with a strategy on developing where and how we could make openings within the different configurations and give a range of solutions. And again, when we're talking about single or multiple optimization, obviously it's great when we can actually propose a range of solutions that, that provide us with an opportunity. So this is block-based, so it has an opportunity to be disassembled and to be reassembled, but how could this be calculated? Because actually when we are developing these systems that have the potential of to be reassembled, or disassembled, the industry doesn't seem to be ready yet to actually go and say, okay, great, let's put this on the market. So what we see here is that actually it is a combination again with standard timber elements. You see here in the middle, this beam that is spanning kind of and linking all of the blocks together. And on the right-hand side, you see as well where we were in their office kind of developing on how to combine these two elements. So in this case, it is still a hybrid, but it has the opportunity. So let's continue then with another block system. So I already explained to you the Tallinn Art Biennale design, which was done by Gilles Retzin. He's also part of our, and they're developing this block-based, volumetric timber block-based system, which you see here. Very simple panels that are just bolted together. Everyone should be able to do it, as you see here. So we incorporated this idea of lazy blocks in order to generate a viable kind of multi-state kind of system where the industry might hopefully be ready for this. So could we reuse blocks to build this structure, which was built in May 21? So this is an image of during construction. Could we use blocks that we already used from another project in Bristol? So we always check when we are doing the design, we're checking the blocks themselves and the rods, and we can find the capacity of use of each of these elements and how much they have been subjected to load. Meaning that if we use the lazy blocks, they haven't been exposed to loading. And for timber, this is important because timber has issues of creep, etc. So that might be a way to say, well, we are exchanging the blocks that we're working harder to then go into lazy blocks for the second configuration. And this might be a way to actually work also with kind of timber in the market of design for dis and reassembly through lazy and active blocks and interchanging them between different states of design. So yeah, how lazy are they? So here's quite funny. So obviously we are always kind of testing, and it's really nice as well to just have here all the builders for the Hackney project sitting on this long beam. So also is everything like this is in any case over designed because there are new systems that we have to prove still to be viable to the to become part of the industry market. So here again we see a bit more testing and linking these together. And here you see Gilles lying on some of these lazy blocks that we could then reuse in the Hackney project. So lazy blocks enable creative reassembly. And that will take me to my final point, built-in legacy. So what is the design domain for change? So Alejandro Aravena has designed projects where we have a flexible kind of design because as you see on the left-hand side, actually has left gaps for then the tenants to be able to fill. So we know what is the future change and we can design in for this load to be part of that construction in its initial state. So obviously this is a good way to use redundancy, and it also has less risk because we know exactly what is going to happen. So typically structures are designed as a single element with one role at one moment in time. But if we go back to this group of elements with no name, and you can imagine already that's happening here in this bridge, which is the Wendduinen bridge on which I worked when I was working for Arab, they have a role at one moment in time, but their role can change. So this role, I know I'm running out of time, so I'm just going to go a bit quicker. This role can be amended by adding or removing elements, because when I add or remove elements, I can increase or locally decrease capacity, but I can also change the load path, meaning I could, for example, create an additional strength in this bridge to be able to take this pylon out, or to create openings if you would imagine this to be a big wall. So this means that the domain, so the range of possibilities, for example, for the change of this bridge is based on adding and removing elements within these clusters that change the capacity as well as the behavior. So this is a little example that maybe makes this again kind of clear. So on the left-hand side, we see a structural analysis and see how much compression there is in the columns. If I would remove the support of the middle column, we see that now the load is transferred to the left side, but actually that is not yet still on its full capacity. So what we can do is remove all of the elements in between. And what has been discussed already earlier today is that in lots of designs, actually, because we want quick construction, actually Jan Knippers mentioned this, we want quick construction, so all the columns have the same size. We actually have this ability to redeploy different load paths. So this is also what we try to do here, again, with the Tallinn Art Biennale project. And what we have been doing is that is my own timer. What we have been doing is trying to recluster elements to make the best performance for one solution. But then in their disassembly, they could be reassembled into new configurations. So here we see some clustering checks of beams and that we did at UCL on the right-hand side. So these blocks are again bolted together, so proper design for disassembly. They form these clusters that can take specific types of load. So the limits of these systems are based on the element capacity, the connection capacity, its ability to cluster, and the amount of elements that we have. So special announcement here. So this is Gilles, and on the left-hand side, so the architect of the project, and on the left-hand side we see Claudia Pasquero. And the special announcement is that we have a multi-state design. Unfortunately, we never built it like that, so we stuck with the one configuration there. So again, this is a shame, because actually it would have showcased the possibility of how we could really interchange or and disassemble and reassemble these discrete elements into different spaces. So the main question there lies to ask, what do we need to preempt to cater for change? So on the left, we have the reclustering of no-name elements. And on the right, we have built-in kind of capacity in Aravena style. So yes, so they're, let's say, different ways of thinking about how to cater for change. And obviously, in the way of Rubens, they're both have more material that might be needed, but have the ability to change in their state. So Rubens design is designed for now and for the future. I hope that you are inspired by thinking about no-name elements and how we could reassemble and how we could build in kind of this little, like either small or big changes for the future. So thank you very much.
Thank you, Manja. Thank you, Manja, for your Rubens lazy active speech where the elements have no name. But for compensation, there was one name that was the most beautiful product name ever, the Black Betty. So let me introduce your respondent, Wolf Mangelsdorf. He studied architecture and civil engineering in Germany and Japan. And he's focused on development of computational engineering, human-centric design approaches, and the industrialization of the construction process. And as of October this year, so just a few days ago, he's professor of structural design at the University of Applied Arts in Vienna. And as far as I know, Wolf, you told me that Manja and Wolf, the both of you know each other still from AA times. So let me just be here the observer. So the stage is yours. We're looking forward to your respondents. And maybe once in a while, I'll be just interrupting you with checking if there is a question from the audience and in also being the keeper of time. So looking forward, go ahead.
Yes, thank you. And thank you, Manja. Great and inspiring talk. Look, I wish I could be sitting there on one of those chairs there in the... unfortunately, I'm sitting in New York in my study, and there's still travel restrictions that don't allow me to do any of this at the moment. But well, next time, I suppose. Inspiring talk, Manja. I think there's the big question here of, you started it with some. I need to go back to your words. Challenging optimization, right? Our industry is obsessed with optimizing for use, optimizing for space configurations, optimizing whatever we can think of. And then actually the most successful buildings, I always believe, are those that are least optimized and those we can bash about and configure to our needs. Yeah, I did a study recently where I looked at what during the design and construction process or the life of a building, where it is configurable and then, or open, then configurable, and then goes to the point of singularity. And we're moving in our design process to that one point where it is just that one thing, right? But actually, if you look over the lifespan of a building, what makes a building successful is where we can then come out of that and give it various different opportunities for life in the future. And I think what you're looking at here is exactly that. I love that. Yeah, I love the idea that you approach this from slightly more fat in there and being able to bash it about in the end. Yeah. A few questions I have though with the configuration system. So while I really like the concept of it being not assigned, and you drive this basically to the extreme limit, right? And are we then, if we are working with these reassembled or reusable, reconfigurable components, or you call them clusters of elements, there's some strict rules about that then though, isn't it? So do I have to call the structural engineer every time I want to reconfigure my assembly, or is this something the user can do?
Yeah. So let's.
Manja, just a second before you answer. May we kindly ask you to stop the screen presentation because otherwise we only see beautiful Rubens. So now we see the two of you.
I would say
okay, great. Sorry.
In my case, that is better. But hey.
Yeah, so actually, I just want to go back to one thing that Mike said. So Mike Weinstock is like a tutor or the director of emerging technologies at design at the AA. And he told me in the beginning where I started to think about this multi-state design. We're never going to design dancing buildings, i.e. meaning they're not going to change, you're not going to pull here and everything like that. But also, I think, even though here maybe I'm proposing like with more pavilion style structures, we could really reassemble and disassemble everything. I think it's interesting where we can make smaller changes, and there is the opportunity to not call the engineer, for example, with the Mohocan, with the hexagonal bricks.
Absolutely, fascinating. Yeah.
Yes, and I have another idea of this waterfall lintel, which we should discuss in a pub. But the idea of, actually building in or understanding load paths of like more likely change, I think is already really good, because we cannot look that far into the future knowing already what is going to happen. I think the opportunity to do some smaller changes for which you might not need your engineer, might be great. And also, I don't mind if an engineer needs to be called. I think then the engineer also has the opportunity, has the opportunity to have greater potential of change of the current stock, because of the way that we understand how we can move, let's say, kind of forces around within one system.
No, okay, that does make sense. So we could see this in two ways, basically. You could see it as something where you get almost like a rule book of changes that you can apply yourself, and like the little number on the panels that you can remove. And or you could reconfigure it. Yes. The other thing that I was really intrigued by was this idea of the lazy elements, right? The lazy elements that reused. One question that sort of popped in my mind when I saw this is, how many lives do they have then in the end? Can they then be, because you make a lazy element into a working element, then the working element could possibly relax a little bit in the new configuration. And
sorry.
Because
I think one thing is the lazy in purely its capacity, and now because we are just unable to present this and reassembly, because I haven't seen it anywhere. Where is this happening, right? So somehow actually, or at least in a different state, using timber or other recycled materials, because more issues, let's say, with creep. If we are recycling concrete or steel, it is maybe more used already. So just talking about the timber aspect of it, like when we are even thinking about CLT or other, like forget about the kind of block system, but if you're thinking about that, it would be interesting to somehow add this to the stock and the understanding of elements and how we could reuse also these elements to a much greater of their capacity than that we would otherwise have to do. So this is a bit kind of engineering, but unfortunately timber elements, they suffer a little bit when they have to load. So I think that's why this is a great way to showcase and yeah, just prove that we can do it in this way. I would also really like to just do it. And it is a simple way for everyone to understand, yeah, that this is a method, but I also appreciate the amount of change that they can have, right? So how often can I actually go kind of through this process? Again, I don't think that this whole process will, like, let's say,
comes back to the dancing building, doesn't it? Yeah, the building
exactly.
will not start to dance. Yeah,
I don't think, I'm not proposing dancing buildings, but I'm proposing something that where, you know, perhaps we could add in a bit of, let's say, a steel structure at the base. We are removing the timber elements and put them then back on top of the steel structure that we have just created and reuse them again. So it is more about the ability, yeah, to reuse them in a non-dancing way fashion.
Yes.
And something that the industry might be open to.
Yes, and some of the examples that you showed, yeah, they were also maybe working more with a hierarchy, where you had more of a rigid frame element, yeah, or something that is already, it's not so easy to change, basically. But then within that, you have more ability to change. I also, what you just said about, you know, maybe taking some of the more standard building materials that are not the blocks that you have purposely designed to be the gold pieces in the cluster, so to speak. Yeah, takes me back to one of the projects that Daniel presented earlier. Yeah, I think he's completely gone now, right? Have I got this right? If he's no longer in the audience, but I found that fascinating to see how the old concrete slabs were basically taken and turned into something different just by adding them to a timber frame and making the connector pieces here. So it'd be fascinating to see how some of the work that maybe I could see is slightly more on the theoretical end of the spectrum in your presentation, how that could be translated into these kind of concepts. Because I think where we are all in full agreement is around two things. We need to be able to reuse material in an intelligent way, and I think you're doing taking all the steps to design it for that. And we need to give the material that the material configurations, yeah, call it buildings, as long a life as possible. And I think that's only achieved by giving it the ability to change with us.
Let me interrupt you shortly.
Go for it.
I would just like to give you, first of all, time-wise structure, and also ask if there is a question in the audience, because
I was just going to ask that too. Yeah,
exactly, because the two of you are greatly communicating with each other, so thank you for that. Is there a question here in the audience? If so, then we would like to address this question to the both of you. One icebreaker. Thank you. Just wait a second. The microphone is being handed over.
Thank you, first of all, Manja, for this amazing lecture. I think beyond the necessity to physically change or modify these configurations that you proposed, I think the great potential of the redundancy, or the quality of the redundancy they also represent, is that within this ambiguous state they are in, they already provide, I believe, multiple functions, perhaps some of which are unknown in the moment you are analyzing them, especially when you're not viewing them only as structures in terms of load-bearing systems, but looking at them architecturally. So I think some of these features these elements provide, with their ambiguous qualities, they could be maybe used for things that were not intended in the beginning. And that, I think, offers a whole new potential of or opportunities for future engagement with the structure in a more dialogue style, as opposed to an optimized structure that is reduced to the bare minimum and is only good at one thing. So I think I guess what I want to say is that maybe it's not necessary to reconfigure these things. Maybe they are versatile in the unchanged state.
Yeah, super comment, because maybe that goes back to the first point, which is the kind of no name, right? And what you call ambiguous. And I think, for example, going back to Wolf, what was the guy's name that you just from the previous speaker?
Daniel.
Daniel, yeah, sorry, forgot.
Was it? I wrote it down. Yeah, but I'll get this wrong, this other stuff. Daniel.
But so with Daniel, because then, yeah, we have this kind of concrete slabs, but okay, maybe it's not a slab. It can be a wall, it can become a stair, become part of a roof, right? So, and I also think when we discuss that, maybe not only as you suggest, you know, from a structural point of view, but also from an architectural point of view, great. And that's why I also hinted at this waterfall kind of lintel, right? Meaning that lintel, we always imagine big beam over opening. But once we kind of eliminate, you know, that way of kind of thinking, I think new opportunities can come of what they can be, either in their initial kind of design state or when they are transformed or need to, you know, have a different performance when I'm amending my building. So yeah, maybe there's a lot of, because obviously I'm also telling you all the ideas that I have, and I'm not saying that this is a watertight concept, but I really, yeah, I like to think more about this kind of no name and the ability of ambiguity.
May I also ask a question to the both of you? Manja, it was the Rubens picture that came into my mind, and I was thinking about Mies van der Rohe, less is more, and now I'm thinking about more is better. And the question to the both of you, Manja, to you and also to Wolf, partner at Herpoldt and now professor for structural design here at the University of Applied Arts, is there also an example in history where you have this Rubens approach in architecture, but not only in ornaments, where we think of historical examples, but also in structure? So is there examples in history, or is this Rubens structure thinking something new?
Do you want to go first, Manja?
Yeah, I should have done my research in history. Actually, also, like, yeah, I'm sure that there's redundancy kind of everywhere, right? Because elements are not only structural, they also provide sound insulation, normal insulation. They are the weight or size because people can carry them, right? So they have been not efficient in the way that we, from our profession, myself and Wolf, from the structural engineering point of view, have to skin them out, right? So I can't really, I'll think a little bit more about an example, but I think this is the, yeah, like there's no need, let's say, to do this and to think only in that one specific aspect. And maybe it's much more going back to the kind of holistic opportunity of that element of what it can bring that, yeah, has been there yeah, for a long time. I have to think about one thing that I also read in a book, and they are building like a small kind of stone extension. And this is where it came from, that, you know, actually the height was just to where people can reach. And so I think the philosophy of what drives what these designs are like, so either skinny, either Rubenesque, or either just because this is how far we can reach. I think this is what we have to bear in mind, that our philosophy or driver for how we intend to design them is the key to, yeah, to what kind of output of structures we are creating.
I'd say I have a bunch of examples that spring to mind. They're pretty Rubens, but not in the sense of that they're made from the gold pieces. They're still made from the chess pieces, if I come back to your analogy here. I live in New York. New York is full of it, right? The entire western part of New York, the harbor front there, or whatever used to be harbor front at the Hudson River, is full of buildings that was designed as warehouses and industrial buildings. And they have a complete revival. And yeah, the most vibrant parts of town are there, I would say, right? And we can use these buildings for anything we want. They have oodles of capacity. Obviously, that comes back to maybe an element of over-design, because they were designed for a different use. And therefore, they're a much higher load and much higher robustness. But they last. Yeah, it's a very simple kind of way of looking at it. We have developed our own concepts, again, with buildings that are built on, with beams and columns and, the named elements, as you call them. Yeah, where we allow for the future adaptation of the named elements. Yeah, so we design from the beginning into our buildings retrofit possibilities for when you have a use change, when you have to have higher loading capacity, and building that extra capacity only in the elements that, basically the foundations and some parts of the columns, where you don't immediately need it. Yeah, I think that it comes a little bit back to what I was trying to say. Are we building a frame within which you are pretty free to do what to do? And I've reconfigured a bunch of these New York buildings, and they are very robust. You can cut out a lot and they don't fall down, or are you basically starting from the beginning with your no-name elements? And I could see it sort of ending up a little bit of both, right? What do you think, Manja? Is it going to be the one or the other, or is it a combination?
I would say
That's
more
the big
that
question of today.
Yeah, exactly. Well, it is a combination, and it is maybe just redefining what kind of optimizing means, right? Because in the end, then what you're proposing, Wolf, is like kind of the Aravena typology, where we know what is going to happen and we kind of cater for that at the start. So,
well, I would say a postulate, I don't know what's going to happen, but hey.
But yes, but let's say
but I give it a framework
hints
within which it can happen. Absolutely, I agree with you.
But I do believe that a framework is good, because this framework then allows you to make smaller changes that have actually really big impact. And that means that maybe the bigger the impact can be is because we have this ambiguity potentially of elements that can change role within the whole system. So that means that still maybe playing with, adopting kind of how loads transfer through the building, which parts that we then try to mobilize more in that have a real potential, aside from making openings or adding something on top. I think I have a hunch, let's say that's the right word, that there's this potential of playing with how loads are transferred and manipulating them within the kind of frame condition.
I think that is a good way to look at it, because oftentimes that's exactly what needs to happen. And the intelligent kind of, the ability to do that intelligently is really set by how far there is already an inbuilt flexibility, I would say, and how far you possibly think about this already in the beginning. And I think there's an important point that you made where we, just had that sort of little conversation around. We don't know what the future looks like and what the building may want to be one day. Who would have thought that the whole of Soho would be what it is today? And it's very difficult, I think, to predict any of this. The more we can go towards a direction where we can have maybe no-name elements that allow that redundancy that you're talking about, maybe that's the answer to some of the flexibility needs that we need to build in. But definitely, I completely agree with you. We need to build longevity into what we do with unpredictable future. Definitely no optimization.
Thank you very much. That sounds very, very specific. So definitely no optimization. And Wolf, may I just quote you at the end of a full conference day, we don't know what the future will be. So next time we have to work harder in order to be able to predict the future. Thank you to both of you.
I'll do my best.
Thank you to both of you for not being lazy today, but being very active and joining us, and for your inputs. Thanks to London, thanks to New York, And now I'll ask the two organizers and initiators, Karin and Lucas, to me on the stage. And to Manja and to Wolf, I would kindly ask for an applause. Thank you.
Thank you.
So, coming to an end for today, Wolf just made a big statement. The future is certainly not about optimization. So you asked a question in the morning, optimization or versatility. Now you have an answer. Let me start with you now, Lucas.
An opinion, let's say.
An opinion, I'm sorry, Wolf. Now you have a very strong opinion. Lucas, are you happy with that?
In a way, I am happy with this because I'm happy about the clarity of the statement, and I think to some extent what I also appreciate and really enjoy in many of the instances or moments throughout the symposium today was the clear position we've seen. It wasn't ambiguous all the time, which I think really helps in combination to see clear parts of the picture. Never maybe the full picture, but it really felt like to me today that I switched my mind constantly, agreeing and disagreeing to different things, and that sort of agreement and disagreement changed over time almost.
Thank you.
So now I'm convinced. Yeah.
Now you're convinced. Karin, are you convinced too?
Yes, I'm very happy because there were so many inspiring ideas today that I think they are a good basis for continuing our work and for the next symposium, which will be in 1 year. And if I refer back to just one expression that I heard some minutes ago, no name elements. This was absolutely fascinating for me. And I think we could take that idea and scale it up. And it reminded me very much of building structures that we have a lot of in Vienna. When we think of all the building stock from the 19th century and turn of the century, and they offer a quality and then an optimization of adaptability, which we should try to regain, because they have a certain luxury in a Rubens structure of a lot of space. So they have high ground floor spaces where which can be used for nearly everything, for shops, for restaurants, for workshops, for whatever, and even all the spaces in the second and third and fourth floor. They are they offer the same flexibility, and you can find offices and flats and kindergartens and even mosques and whatever. Yeah. So I think this is also a kind of redundancy that we should try to achieve, apart from this engineering redundancy.
Lucas, are you visioning a future with elements that have no name, or with elements that do have a name? It's a day full of polarization.
Mm-hmm. Honestly, I prefer things with names, but maybe the naming system has to be rethought. Maybe these elements can have names, but the categories that this naming, maybe if there is such thing as a naming system for those, is maybe belonging to a different realm, maybe not to their structural function within the building, but to, I don't know, some other logic. And what I think is amazing about these sort of different views that we've seen today is that there is different approaches to robustness in a way, and this sort of capacity for flexibility or change on one hand, but also the different means of producing or actually fabricating things also address robustness in a way, and that's why maybe that goes a little bit far, but I'm glad, Manja, that you didn't mention automation today, because other people from in this field are very much invested in the automation part of the building blocks, discrete element idea, and comparing this to the democratization of architectural fabrication and some other examples we've seen today, I think it makes it possible to align or to make these two ideas, the democracy idea and the building block idea, come closer.
Thank you very much. Automation will open a completely new field, maybe for next time. And this brings me to the final question to Karin. We had a circular strategies symposium last year where you decided to focus on, from the very beginning, from the product to process, to engineering, to construction site, to building, and to urban landscape scales. Today we're talking about optimization or versatility. Is there an idea for next year? What are the next steps?
Not really. We have a lot of ideas, but we have not decided yet what we will focus on. But I guess it will be interesting as well.
I have an idea, but I can
share it with the public?
Yes, this time I will. I have the feeling we are going to think a lot about standardization. Maybe that's something that will come up.
And when I think about
time.
Today's discussion, I can tell you that this will be a very emotional topic. Thank you very much. Thank you very much for your effort and for putting together so many strong positions today. For me, there were many new impulses. It was a day full of contradictions, and as you said, I was also changing my minds all the time. So a lot of going on in my brain. So thank you to the both of you and to the University of Applied Arts for making this possible. You're still having your microphones. Would you like to add something? Would you like to make a final statement, conclusion, or shall I do that?
Thank you, Wojtek, for your nice work. Thank you to the audience who came, who found a way, although all we have become a little lazy and prefer to listen to events like that from our sofa. Hopefully times will change and this auditorium will be full again with people. Maybe next year we succeed in having that.
Thank you very much. Thanks for coming.
Thank you so much, guys.
Thank you.
Thank you.
I was just telling Wolf, he's going to let me know when he's in Vienna and then we all meet. So let's say in a couple of months, when also my baby is a bit older, like let's all meet. I'm looking forward to have dinner and drink.
That's a perfect idea.
Great.
Yeah.
See you guys.